can take each of those tasks or a setup process and try to find the right model for each one, then build the model pipeline, data pipeline. So that will become an end-to-end process. That will become an end-to-end process. Option B, if you don't want to go that far, if you want to use tools like Automation Anywhere, Blue Prism, or any other tools in the industry, so that also possible. So if you use that tools, what does that mean? So those tools may not have self-learning technique, okay? It could be instruction driven, but ultimately they do work without a human, okay? So what I'm trying to conclude, in robotic process automation, the machine learns and understands business processes and its characteristics. Business processes and its characteristics. What are all general business process that what we may have seen in our industry? Examples, order to cash. You place an order, collect the cash. That is one set of process. Procure to pay. You procure and then make a payment. Okay, procure and then make a payment. That is another set of process. Record to report. You create set of transactional records and report them. Correct? You create a set of transactional records and report them. Example, employee HR, onboard an employee and report an employee payroll. Okay, so that is record to reports. So you have a record about an employee, you report them. How they're performing, what is their quarterly earnings, what is their annual earnings, what's the monthly earnings, you can report them. So those are all typical process, but it's not only what I said, it could be any process. It could be any process. Financial close, it's a process, okay? Financial close is a process like this, any process. If you want to teach a machine so the machine can understand, then it's a robotic process automation. All right, the next one is, I'm not teaching the machine about a business process, but I'm teaching the machine about language, okay? I want to teach the machine about a language, both written and spoken, both written and spoken. So I want the machine to understand the language that what I speak. I also want the machine to understand the language what I write. Okay. So for example, you have seen that the machine can detect the human written hand digits, correct? So whatever you write, the machine detects and tells you what is this? It's basically number 4, number 5, number 3, whatever. Or in some cases you told Siri or Alexa or any other tools that you have seen actually, it kind of communicates with you. It kind of interacts with you. How does that possible? So if you are trying to teach a machine where the machine learns and understands about a language, that falls under language processing. Under natural language processing, the machine learns and understands about language, both spoken and written. In what form that could be delivered, sentence classification, word classification, language modeling, okay? Like this, there are different techniques you could use. For example, on your cell phone, okay? On your cell phone. So if you're typing a text, if you're using a smartphone, at the bottom of this type, correct? It forms a sentence. It forms the sentence. So that's a sentence formation, okay? So that is built on NLP, natural language processing, okay? The model could be different, but I'm saying the framework on which the machines are learning. So if you want to teach a machine where the machine learns about languages, both written and spoken, okay, that could fall under natural language processing. So that involves language modeling, sentence classification, word classifying, sentence formation, etc. So let's say I'm not interested in business process. I'm not interested in language. I want to teach the machine where the machine can understand vision. What is vision? Whatever you see in front of you, that's a vision. I can see a dog in front of me. I can see a car in front of me. I can see a snake in front of me. What is that? Those are all vision. Those are all vision. So if you want to teach the machine where the machine can understand about an image, okay? An image means it could be a human, it could be an object, it could be an animal, it could be whatever, okay? So if a machine needs to understand this, then that falls under computer vision. Under computer vision, the machine learns about image and its characteristics. So what exactly it's doing? Image recognition, human recognition, object recognition, gender detection, all these things falls under computer vision, okay? The example, on a self-driving car, when a car is driving at a constant speed, it sees a red light, it sees a green light, it sees an yellow light. So based on whatever it is, it takes an action. So that's computer vision. It understands the objects, then take its own decision. Correct? It understands there's a red light. If it's a red light, what am I going to do? I'm going to stop immediately. If it's a green light, I'm going to move. If it's a yellow light, I'm going to slow down. So how does the machine learn all these things? That's basically in a object detection, object recognition, correct? So image recognition, all these things are used actually. So that falls under computer vision. Okay, that falls under computer vision. So we talked about robotic process automation, where the machine learns and understands about a business process. natural language processing, where the machine learns and understands about a language, both written and spoken. So whatever you speak, the machine understands. Whatever you write, the machine understands. So that's how you want to build an application. The next is, I want to teach the machine about an image, or I want to teach the image about a video, or I want to teach the image machine about like an object. How could I do? That falls under computer vision. That falls under computer vision. All right. Now let's get into, okay, what is, yes, question? All right. Please keep your phone on mute. Let's move on. Okay. So now let's understand what is deep learning. Okay. So technically, the first one should be type of machine learning, but I just for now leave it. Okay. So what does deep learning does? Okay. So again, keep in mind, there are so many different definitions out there. Deep learning is an extension of machine learning. Machine learning is part of artificial intelligence. Correct? You see the circle, three circle, it's just floating around everywhere. Okay. So people put a big circle and that call artificial intelligence. Inside a small circle, they call, this is basically like, machine learning. Then a small circle inside of machine learning, they call deep learning. Correct? These are all right. I'm not saying no to that. Okay. So it fundamentally, what is that under deep learning, what machine does? Okay. So keep in mind, these are all different teaching technique for machine to learn certain things. Okay. Different teaching technique to teach the machine so the machine can understand. Under deep learning, the learning method, okay, of a machine learns, it's quite different. Okay. It's quite different. So it learns in a different approach. Okay? The approach that takes the machine to learn, it's different. What is it? We are going to see. So the deep learning primarily used for, it is not specific to language or a vision or a process, any complex problems. Okay, if you want to teach a machine, okay, about a complex problem, such as someone talked in the beginning, credit score. Okay, so I wanted to give a loan to someone, but before I give the loan, I want to run a credit profile. I wanted to make sure actually, like, the person who was seeing has enough credit history so that I can confidently give a loan. In that case, the problem is quite intense. Why? So I need to know the person's earning potential, employment history, educational background, social background, personal background, family, all this I need to understand. So the data is quite intense. It's a lot of multidisciplinary data sets. And also the problem itself quite complex, correct? So in that case, I will be applying deep learning. Okay. Under deep learning, the machine learns complex problems and its data sets in a different approach. So what approach? It's almost like a human brain cell. Okay? How does our human brain cell works in that approach? I will explain more in detail, but I want you to understand. So when to use deep learning or what it does actually. So if your problem is quite complex, it's very data intense. In that case, you will be using a deep learning technique where the machine learns complex data sets and its pattern, and the problem itself is quite complex. It doesn't know what hypothesis it takes to solve this problem. So under such situations, I'll be using deep learning. Okay. All right. The machine learning first one, it technically supervised, unsupervised reinforcement learning. So it is the most simple, easiest way to train the machine. Okay. So these are all different techniques. Keep in mind. So here I'm training process. Here I'm training language. Here I'm training computer vision. It's the object, image, videos. And here complex problem. Here simple problems. Okay, here I'm training the machine to understand some basic simple problems. Correct? Is it going to rain today? Yes or no? Yes, it's going to rain. Is this person going to pass or fail? Yes, this person is going to fail. Is my mom is going to make cooking today? Yes or no? Yes, it's going to be. Correct? Or how much this house is going to cost? It's about $100,000. How much this car is going to cost? It's $200,000. How much person is making as a salary? So 200,000. So what is the scale of 1 to 5? This person is going to be like my best friend. Correct? So like this, if you want to do simple problem solving, if you want to teach the machine to understand simple problem solving technique, so that falls under supervised, unsupervised reinforcement learning. Correct? So that is basically so one of the things that what we talked about. Correct? So this is what I'm talking. Okay. So let me fix this one. Okay. So in all five cases, correct? So the machine learns and understands. In all five cases, the machine learns and understands the problem solving technique. Okay. Different problem solving technique. So when people say machine learning, it is just not only this, it includes everything. Okay? So the machine learning by definition tells you, you teach and train a machine. That's what it is. How do I teach and what do I teach is what this is all about. Okay? How do I teach? What do I teach? Like I said, the learning experience in deep learning is different than a supervised machine learning. Okay, the learning experience for a machine, it's different in deep learning than in a supervised machine learning. Under supervised machine learning, the machine learns based on a guided instruction. Okay, guided instruction. You give instruction, the machine learns and understand. Under deep learning, I don't give such guide. It itself figures out. It itself figures out. Right. So what you have to do, you have to understand when you are trying to solve a problem. Okay, when you are trying to solve a problem. For example, I'm just going to simply show you one example. Okay, so one of the problems that I was asked to do at the beginning. So I'm just going there. Okay, so how does it works? Okay, 1 second. I'm just going to the right slide. I don't know where it's in this. Yes. So, like for example, this is one of the use case. Predict customer usage churn and when and why. Okay, so that's the problem. So now I need to see where does this problem fall center. Is it a business problem, business process problem, or is it language-oriented problem, or is it a computer vision-oriented problem, or do I need a deep learning technique, or can I use a simple supervised learning? Correct? That is my first immediate step. Okay, so that's my first immediate steps. So that is what we were talking about. Okay, I'm just looking for a specific slide. 1 second. I may not have in this one actually. That's fine. So the problem what you're trying to solve would dictate which one to use here. Okay, what technique to use here. So what I'm trying to say, okay, I'm trying to say out of all, which one I have to use and when to use what. So that will be dictated based on the problem that you are trying to solve. If I'm trying to solve a problem where I want to detect a gender, okay, a customer comes to my store based on whether the customer is male or female, whether the customer is an Indian or Chinese, I want to make some recommendation. So that could be fall under computer vision. So what does that mean? I have to train the machine can understand images. So there are certain libraries, functions we will be using, which is very relevant for computer vision. Okay, very relevant for computer vision. Okay, so in summary, there are different techniques you can teach the machine, so the machine can learn and understand problem solving technique, which is learning algorithm, which builds the learning algorithm. So what do you teach the machine and how the machine learns, it differs based on the type of problem you're tackling. So here I'm summarizing whatever you want to do. Okay, whatever you want to do, there are 5 different ways you can train and teach the machine and build a learning algorithm. If you want to teach the machine to understand a business process, that falls under robotic process automation. If you want to teach the machine where the machine can learn and understand languages, both spoken and written, natural language processing. If you wanted to understand what the machine can detect about an image or object which sees in front of it, computer vision. If I want to go on a different level where I don't have a way to solve this problem, I want the machine itself to figure out, and the problem is quite complex, then I will go for a deep learning problem. Because in that approach, the machine learns in a different learning technique, uses a different learning technique, then it creates different learning algorithm based on the underlying complex data sets. My problem is complex, my data set is complex, and I don't have a hypothesis to arrive something, then deep learning. So my problem is simple, and I have a guided approach for the machine to learn, then I will go any one of these things, supervised, unsupervised reinforcement. I will cover each one in detail later. So this is to set the stage, to make sure you understand, correct? This is set the stage to make you understand. If you want to master, okay, if you want to be an expert in the AI space, you must have to understand all the 5 different techniques. And also you have to be able to build models, algorithms on each one of these, correct? Maybe some handful examples so that you can understand what exactly how it is working. Then you can specialize in any one of them. Some of them could be specialized in natural language processing. Some of them could be very good in deep learning. Some of them could be in simple machine learning techniques, correct? Like this, it all depends on the individuals, but I just wanted to lay out the grounds. If your goal is to become an expert, if your goal is to become a subject matter resource in the space of artificial intelligence, these are all expected. Okay, these are all expected. If you want to specialize, I can understand, I can build models, correct, on machine to learn and understand about a language. I speak in Tamil, the machine learner understands Tamil. I speak in Telugu, the machine learns and understands Telugu. Okay, so how could I build such applications? Then it falls under natural language processing. All right, so these are the 5 different core building blocks. In my mind, it's most critical. Okay, so again, each one I'll touch more in detail, you'll understand, but at the high level, what you have to do if your goal is to become a subject matter expert or a scientist or an engineer, whatever you may be in the space of AI, make sure you understand all the 5 technique. Make sure you are in a position to build simple models and make sure you are able to understand how it works all together. In some cases, you build all of them together. Okay, it is just not only language processing or a computer vision. You could build all of them together. You could build all of them together. All right, let's take a question. Saranya, what's your question? Saranya, I know you raised your hands.
Yeah. So I can understand the classification between robotic processing, natural language, and computer vision. But I mean, ML and deep learning, at what stage do you measure the complexity? When should I decide I should go for deep learning or just use normal ML?
Sure. I'm trying to look for a slide. Give me 1 minute. So this is how I would approach. Okay. So the model selection, okay, should be driven based on a problem statement. Okay. The model selection would be driven based on a problem statement. Example, is Saranya going to get A grade in the next semester? Okay. How do I know? I can go back and look at all the assignment, all the quizzes, all the things, whatever Saranya did. With that, I can arrive at prediction. Is that simple or complex? I would say it's a very simple, basic things. Okay. Now let's take another side. I want to run a predictive model which predicts behavior of Saranya in a classroom based on a facial expression. How does she react? Okay. How does she respond to certain questions? So in that case, I'm not looking at your assignment. I'm not looking at your coursework. I'm not looking at any quizzes that what you took. I'm completely monitoring your face. Correct? I have a sensor which gives me data, your facial expression. So now I have no hypothesis. Correct? When I say no hypothesis, so how does you behave when you don't understand certain concepts? I don't know that. Or how do you react when you ask a tough question? I don't know that. Those are all behavioral expression. So when I don't have a hypothesis to solve such problem, then I would let machine to figure out what is the hypothesis itself. In that case, I will go deep learning. Okay, why? Number one, I don't have a pre-defined set of features where I can go and say, these are the 20 things I'm going to look for, like in assignment, like in quizzes, correct? So I can see in your first semester, you got all A. In second semester, you got all B. In third semester, A. In fourth semester, between A plus, A minus, like this. I see a pattern there. So based on the pattern, I can tell what's going to be next. That's a prediction. Okay, it learns and understands. But understanding your facial expression, arrive a state of whether you are listening to the class, not listening to the class, I don't have a hypothesis. When I don't have, what is hypothesis in this case? The future for the machine to understand what I'm looking for, whether it's a good listener, bad listener, and average listener, correct? I don't have that hypothesis. So when I don't have such hypothesis, I need to build that hypothesis. How do I build? You can't build in a simple machine learning model, which is supervised machine learning or any other model that you could choose. So in that case, you go deep learning. So deep learning where you don't have a hypothesis to solve a problem. You expect machine to arrive at the hypothesis and also the complex data set, which is going to make process quite complex, very intense. So under circumstances, I will choose deep learning. I hope this helps you.
Okay, I kind of understand it, sir. So when I don't understand what features to select, I go for deep learning.
That is one of the criteria. That is one of the criteria. I literally don't know how do you behave, correct? Like, if I ask a tough question, what is your reaction? I'm not talking about a reaction on what is you're going to write in written, facial expression, correct? Facial expression, angry is different. Like, happiness is different, correct? So these are all, sadness is different. So each people have a different way of representing something, correct? How do I understand that? So that is why I said I have no hypothesis, no way of telling what feature I'm going to look in your facial expression, correct? So that the machine has to understand and figure this out.
Got it, sir. Thank you.
No problem. All right. So I know a lot of you have dreams to get into. I'm sure it's possible, but it's just a matter of putting ourselves in this mode. Okay, so let me summarize what I did so far. So I explained to you what is artificial intelligence by definition. What can we do with artificial intelligence for business, or in what form it is delivered? Number one, an intelligent automation. Number two, data science. Combine these two, digital transformation. So how do you build artificially intelligence? Okay? How do you create intelligence artificially? So what we learned and understood. So instead of teaching a human, instead of training a human, now you train a machine. When I say machine, it is not just only a laptop or a desktop or a server. It could be anything. That is where industrial equipments are coming into picture. So the need is not a laptop, desktop, or any servers. The need is building industrial equipments. Keep in mind, industrial automation. That is the real need. And that is where the huge opportunity potentials are. I am not saying these companies are going to vanish. Okay. 10 years from now, we may not even have an ERP package. Okay. I'm telling you, we may not even have an ERP package. There are companies very dominant player in ERP. Okay. There are companies very dominant player in human resource. There are companies, because these are all hard-coded instruction. The ultimate aim is, ultimate aim is to do not hard code any instruction. Let the machine learn those instructions, correct? So till date, what we have built so far, we written tons and tons of code, okay? Tons and tons of code. Those codes are hard-coded rules we wanted to avoid. We don't want to hard-code anything. In that context, do not teach a machine, do not teach a human, teach a machine. What a human can do, human cannot code, human can do programming, that is not required, okay? Keep in mind, I'm not saying we don't want to do any programming. We do want to do programming, but the level of programming is different, not on a business application. It is very systematic, system level applications, system level interfaces, very, very complex, intense programming, right? So as I told you, when I type a cell phone, okay, in a cell phone message, I'm typing like, I would like to order pizza. Immediately, I get 3 coupons. How does it possible? And that is what artificial intelligence. It understands what you type. It immediately looks for the neighborhood, what pizza place is offering discount. So my goal is to what? Want you to buy my products. Then I am willing to send you a coupon immediately. Okay, out of all the competitor, I can go 30%. Doesn't matter what they're doing, correct? So these are all become very vital, integral part of our life. Okay, very vital, integral part of life. That's the level of automation we are talking. Not sitting and coding in C++, Java, or Python, none. Correct? Not in that level. It's pretty advanced. Okay, it's pretty advanced. So far, that's what we understood. Okay, so to build either an intelligent automation or a data science or a digital transformation, we have to teach the machine instead of a human. How do we teach the machine? These are the different techniques. Okay, what are the 5 different techniques? Robotic process automation, where the machine learns about a business process. Natural language processing, where the machine learns about a language both spoken and written. Computer vision, where the machine learns and understands about image, object characteristics, videos. Deep learning, where I don't have a way to solve a problem, or the problem itself quite complex, and data is quite intense, I can't handle these things. So in such situation, where I expect the machine to do everything by itself, then it's a deep learning. It's a very simple, it's not a complex problem, it's a very simple routine day-to-day life, simple things. Then I can use any one of the supervised, unsupervised reinforcement learning, right? So again, it is a very conceptual level. We still have to dive deep, okay? We still have to dive deep. So now let's understand what is machine learning. Okay, same thing. So a teacher, what the teacher does, okay, the teacher is teaching for the students. So what happened to the students? The students are gaining skills and expertise. So what the students become? They become a human intelligence. What does it mean? Either a lawyer or an attorney or a doctor or a physician, correct? So whatever they do, they're all human intelligence. Okay, so this is what we have been doing right now. If you look at our school system, if you look at our college, look at our university. So what we teach in the schools and colleges and universities, we teach students to gain skills and expertise. An engineer, mechanical engineer, become a mechanical engineer in some company, like, okay, ABB. So you're a mechanical engineer in ABB, okay, or you are a mechanical in Siemens. You do that. Like a civil engineer, Cushman and Wakefield. I'm going to work for Cushman and Wakefield as a civil engineer. So what is this? These are all human intelligence. In the same way, we want to teach a machine. Instead of creating human intelligence, now create a machine intelligence. That's the goal. So the objective of machine learning, create machine intelligence instead of a human intelligence. That's the objective. In the same way, whatever we do for our students, our kids to teach, same way you teach the machine. Okay, so this is basically teaching machine, training machine. This is called machine learning. Like students, the machine learns and from the training. All right, so what we teach the students, okay, so in the current, I'm going to skip this one, that's not required. Okay, this also we kind of covered actually. So now let's understand what is that we need to teach a machine. Okay, so as a student, what we have a textbook, we have learning materials like videos, lab exercise, audios. We can listen to something. Okay, we can listen to something, and we can also look at something. Correct? So these are the learning material for a student. Okay, if your son or a daughter or a grandson or granddaughter, friend, mother, father, whatever, if they want to learn something, they have to have either a textbook or some learning material. Either it could be in a YouTube video, or it could be some lab collabs, or it could be an audio tape, someone you want to listen. All these are all learning material. When it comes to teaching a machine, we don't teach the machine using these things. Correct? These are all brought in a different form. It could be brought in the form of data. A textbook could be brought in the form of data. When you say data, there are two key components comes into picture, which is big data and IoT. Okay, big data and IoT. So big data, basically, it is something that, like, you all experienced. It's like Facebook. In Facebook, you don't know how many people can in at any given point in time in Facebook. It could be 100, it could be 1,000, it could be 1 million, it could be 1 billion. It supports. So that is the underlying platform. It scales at the speed in which the users are coming in. So if we want to teach the machine needs data. What kind of data we are talking about? Big data or data from machines, sensors, devices. That's the industrial Internet of Things. Okay? So what I'm trying to say, so we understand we want to create intelligence artificially. How to teach the machine. How to teach the machine, we need data. What kind of data? Big data, IoT. In my view, all these three has to go together. Big data, IoT, all of them in big data, IoT, AI has to go together. Okay, so this is one of the projects that I worked on in a very large telecom company. Okay, very large telecom company. Okay, so in this telecom company, what I used actually as a platform, this is what I'm going to show you. So I have a combination of these three working together. An IoT platform where I can collect and get cell phone data, which is basically either a cell phone text message or a cell phone voice or a cell phone video. So whatever you send, all we get through IoT. It's stored in a big data platform. On top of it, we run AI models. Okay? So that's what I'm talking here. Okay, that's what I'm talking here. So in order for the machine to learn, what we need basically, like, data. In what form the data is brought in? The data is brought in the form of big data and IoT. All right. So I'm going to complete this. Then I'll take a question. I saw someone is raising hand. So in order to train the machine, what is the workflow? Okay, again, it's a very high level. There's a lot to it. Okay, there's very high level. There's a lot to it actually. But at least I want you to understand. You can't simply take a machine. You can go ahead and train a machine. We have to have a problem statement. What is the problem that we are trying to solve? So the problem that I'm trying to solve, either I'm trying to make a recommendation to a product. Correct? So I'm running a retail store. When a customer comes into my store, I want to make some recommendation. I want a restaurant. Excuse me. I want a restaurant. When a customer comes to my store, instead of customer placing an order, I can make a recommendation. Hey, based on your last 2 months visits or 3 months visit, so these are the 10 things you like. Today's Monday, you like pastrami. Can I make you pastrami? I want to build an intelligence, correct? Such intelligence, basically, like, what we are talking problem statements. When a customer comes to the store, instead of customer waiting in the line for 10, 15 minutes and place an order, I want to go ahead and ask the customer as soon as the customer enters the store, so the customer can save the time. Hey, today's Monday, you like pastrami? Can I make a pastrami sandwich? Correct? Yes, I like it. So that is your problem statement. The first step is problem statement. Second, what kind of machine learning model we have to select? Okay, so this is the question Saranya was asking. So can I go machine learning, simple machine learning, which is supervised, unsupervised, reinforcement? Can I go deep learning? Is it do I need to build some kind of, like, language modeling or sentence classification? So I have to know the problem before I go for model selection. Once you select the model and collect the data that is required for train the machine. Once you train the machine, then basically the machine creates a learning algorithm. Okay, teach and train machine. Then see how well the machine is trained. Then the testing the machine and verify the model outcome. So whatever the test that gives an outcome, that outcome, basically we talked about model outcome. So model outcome, is it up to your expectation? No, it is not. If it is not, then I have to go back and do this training again. Then come back here. It's a cyclic process. So now model is ready, outcome is ready. Then I'm going to deploy in a production. So this is where I build model pipeline. The model pipeline from A to Z, okay? From anything, everything what you touch, every model that is touched, it all has to go in a one single funnel, correct tunnel. So it's going to work like a pipeline. So then that is done. Retrain the model, retest the model, deploy the model, etc. So based on how this is going to be structured. Again, all these are all very high level. Okay, there are key to take away in this one. Make a note: model pipeline, data pipeline. That's the key. In the entire process, except the problem statement, rest everything has two connector, a model pipeline, data pipeline. What is model pipeline? What is data pipeline? We'll see. So overall, the process involves to build intelligence artificially. Okay, build intelligence artificially. What does that mean? Yeah, let's take an example. Saranya goes to a restaurant. She likes Indian food. She goes to an Indian restaurant. So what we are trying to do, instead of a server coming and ask her what food she likes to order, we already wanted to recommend her as soon as she enters to the store. We have a digital boardroom in the restaurant. The moment Saranya enters, we capture her face. It's a facial recognition. It falls under computer vision. So then we look at her previous history. What kind of food she liked. Okay, I know she's been coming here for 1 year and she likes pastrami sandwich. Today is a Monday. So I would say, hey, today's Monday. Would you like to have pastrami sandwich? Yes. Okay, I know you ordered last time. Are you hungry? Do you want to go for regular? So building such a conversation without a server, correct? Without a person who's taking this order, without a human, is what our problem is. How do we do? For that, what kind of model I need? So to recognize Saranya's face, I need a computer vision, facial recognition. Second, to go out and look at what she was done, and then come back with a prediction of products you like. That's a simple machine. It could be decision tree, or it could be random forest, correct? All right. So how can I go and solve whether the Saranya is already known to my system or not? It's basically customer recognition. Okay, this customer is known to me. So that could be in a facial recognition model. It's a part of deep learning, CNN model I could use. So all the things falls under here. Okay, then collecting relevant data. That's a model pipeline. Then teach and train the machine. Then test the machine. Then validate the machine. Based on the validation, deploy. Once you deploy, continue to train, continue to test, continue to monitor, and do so. Correct? So this entire process, what I call at a high level workflow. Again, it all varies based on platform, tools, and technology, what you use. It all varies. I have two projects right now. In one project, I completely work on SAP side. Okay, it's on SAP landscape. And other, it's completely on open source. But as a process, I follow both. Okay, I follow in both the cases. I follow this one. When I'm doing for an SAP customer, it's same process. When I do for a customer who's using open source, I do the same process. As a process, I do the same thing. But depends on the technology, depends on the solutions. It could vary on various components, correct, as needed. But at a high level, this is the workflow that's involved. All right. So before we go to the next question, I saw some questions. People are raising hands. Let's bring them. All right. What's your question? I saw someone raising hands and all. So if there any question, Selvi, what's your question, Selvi? Can you hear us? We can hear you, Selvi. All right, let's move on. Next. Someone can unmute. Yes, someone can unmute Selvi. Selvi, can you hear us? All right, so, but we can hear you, Selvi. There could be some problem at your side. Do you want to post the question? We can see what's your question. Let us give a try it out.
Can you ask a question?
Yes.
Me?
Yeah, please. This time is for question, asking question. Please go ahead.
Oh, okay. As you say, like the machine learning, it's more of like teaching the machine, right? It should be machine teaching maybe. And what kind of inputs we have to give for the machine learn to teach the machine? What kind of inputs?
Sure. So can you give me one problem that you want to solve using machine learning? Give me one problem, I'll tell you what input you have to give. Can you give me one?
I don't have any knowledge on machine learning. It is
no,
very new to
you don't
me.
have
I'm
to.
just trying to understand.
Hold on. You don't have to have any knowledge. I'm saying on your day-to-day life, correct? On your day-to-day life, give me one problem. We will use machine to solve that problem. Give me one problem. This is the problem. Example, correct? I'm tired of cooking. I don't want to cook anymore. correct? So that's the problem I'm facing. Or, okay, I'm tired of responding to all this email. Okay, so I wanted to have some kind of an automation. The machine can answer these questions, correct? Like this, can you give me one problem? I will tell you what input the machine needs, so that it's easy for it to understand. So
when you
keep
were
in mind,
teaching,
keep in mind, any problem, whatever you think a human can do. Human means just not you and I, anyone in the world, whatever problem a human can solve, all those problems can also be solved by a machine. I know it's a very powerful statement, but that's where we are heading towards, right? So whatever a human can solve, whatever you do, whatever I do, your father, mother, my father, mother, my kids, your kids, whatever it is, right?
okay.
Any problem can be solved
Right
by a
now, I
machine.
can think of that cash register. You know, if
Sure.
somebody is giving me some amount of money and I'm calculating and giving the change, that kind of
Sure.
problem.
Let's take an example. You run a restaurant. Let's put it black and white. Right? Let's assume that you're running a restaurant. A customer comes to your store and then they had food. Now they're ready to pay. So when they want to pay, you have options. Either they can use credit card or they can use a cash. Correct? Let's take an example of cash. In cash transactions, correct? In cash transactions, basically what happens? So you give a receipt, the customer gives an amount more than what they were supposed to pay. Let's say the transaction that what you're talking about $15, but they gave you $20. So what you do in your cash register, you enter the amount 20, it records, then opens the door and let you take the change and give it to them. Let's assume we want to automate this process. Hypothetically, okay? So this all falls under an industrial equipment, building an equipment at this magnitude. Let's assume that we are trying to build this one for the machine to understand. So what is the input that I need to know? I need to pass on to the machine so that the machine can understand. So the machine needs to understand first the total amount to be built, right? So $20. Okay, that means when you create a receipt, so that receipt has the total amounts, right? So based on the item they ordered, they ate, so you have total amount. So in order for the machine to learn, one of the input could be the amount that how much you have to bill. The second input for the machine to learn and how much the customer giving as a cash. So that means the intake from the customer, that goes an input. So one is receipt, the second one is intake from the customer. And third, the difference between these two, correct? So the receipt, the first one input has $20, $15, but the second is a $20. The difference between these two is what you have to give them back, correct? So at a high level, if I have to build a model to teach the machine to understand these things, number one, I need all your receipts. Okay. Number two, once I have this one, the machine learns and understand what is the receipt amount. The second is the customer input. In this case, how much cash the customer is giving. That's my second input. And the third input is the difference between these two. Okay. How much this? So this is what I have to give. So in a simple way, you can create an Excel spreadsheet. Column one, receipt. Column two, customer input. Column three, difference. The machine learns and understands the patterns. Okay. So then once it learns and understands, then you can deploy the machine in your system. So in the what form? It could be in a form of an intelligent automation where you build an equipment and that takes care. Or a piece of software runs in a system, it takes care. So answer to your question, what input I should give the machine so that the machine can learn, it's based on the problem you're solving. So in your case, you don't want to open the cash register and type the amount, open the cash drawer and give a cash back to the customer. Instead of that, all it is, the moment you create a receipt, the receipt goes to the machine in a live system. Now the machine got it. That's input one. Now it needs an input two. Now the customer put a cash on top of the machine, correct? So you're not there. So you have a scale. The customer puts the cash on the top of the machine. The machine scans and understands the $20 bill. So once it learns and understands, it has the difference between. So in this case, there's the actual transaction, $15. The cash is given $20. And now I'm giving back a change. It opens the drawer and gives a change. How does it work? So the scanning of the currency could be in a image recognition. It understands the image or it understands an object. Okay, so it could be an object recognition. It's part of computer vision. So it tells this is a $20 bill. Okay. Second, reads the data and understands what the amount that is going to be billed. So that is a simple data entry. It doesn't need to be a machine learning model. The difference between these two, that's the logic you have to build. Opening the machine drawer automatically. So that could be a piece of software. It's an instruction that is given to this one. So this is how you build the automation. I hope this helps you.
Yeah, thank you. And also in medical field, hope I feel like going through your slides, Is that the pacemaker is kind of an artificial intelligence?
So everything could be artificial intelligence as long as if it self-learns. If it doesn't self-learn, it's not an artificial intelligence, it's an instruction-driven. That's the rule of thumb, right? So the rule of thumb, so like for example, you teach your son 2 plus 2, 4, 4 plus 4, 8, 8 plus 7 is 16. All right, you're done, your son is learned. Now you're going back and giving in another set of problem. What is 3 plus 3? Okay, what is 6 plus 6? What is 9 plus 9, etc. So based on what you thought, your son is now doing by himself. So that is called self-learning, correct? You don't have to sit down with your son and teach again and again and again, correct? So once you thought your son, hey, 2 plus 2, 4, this is the logic you have to follow. So now your son understand how to add two numbers, how to multiply two numbers, how to divide two numbers. So once he learned the art, when you give a different set of numbers, he does by himself. That is called self-learning, correct? Because you're not teaching that point. You give the problem.
I got it. So the pacemaker also, it operates itself, right?
Again, operating itself could be instruction driven. That's the point I'm trying to make, correct? You can you can give instruction, do this and do that, correct? But when a change occurs, like in your son case, you are telling to do 2 plus 2, you are teaching him 2 plus 2, 4 plus 4, 8 plus 8, etc. He got it, he learned it. Now the change occurred. What is the change? You're not giving 2 plus 2. Now you're giving 9 plus 9. Now you're giving 10 plus 10. Now you're giving 12 plus 12.
Understands that and
exactly.
does it.
Exactly. That is called self-learning. Okay, that is called self-learning. So whatever piece of software or an equipment or a machine, what you see, if the machine calls artificially created intelligence, that has to self-learn. You don't have to instruct, you don't have to programmatically control that.
Thank you. Thank you.
All right. Any other questions?
Hi, I have a question here.
Yes, madam.
I just wanted to know from your experience, what are some of the use cases that you have come up with, you have encountered for deep learning? Because this seems to be one step maybe higher than
Sure.
AI.
Sure. So I'm not saying I know everything, and I'm not saying I'm the only person who knows everything. So these are the use cases that I have done. So these are the use cases for healthcare. Okay. So in healthcare, we have done, I'm going to cover all of those since you asked the question, I'm bringing it up. So I have use case for health risk. So for example, company like Kaiser, Blue Shield of California, or Blue Cross. So these companies are selling premium healthcare, correct? So when an employer group comes for a contract negotiation, I want to have a risk score. You have 1,000 population. Out of 1,000 population, 50% of our population are very high risk. So that means your premium is going to go up. How do you know it's a high risk? So I have a model with predict and tells me the health score. So what does that mean? Their behavior, their lifestyle, their fitness, their clinical conditions, etc., etc. By using that, I run a deep learning model. Okay, so the deep learning model predicts and tells me the health risk of a patient. Adherence, that means you ask the patient to take this medication. So based on his body condition, I don't think he or she took the medication. They're not taking the medication. That's a high risk. Correct. So like this, I have use case for health. I have use case for consumer. I have use case for energy, or whatever you want to talk, I'm ready to talk.
Selvi, you had some questions, so are you done?
Yes. I hope you can hear me now.
Yes.
Yes.
Hi. My question is on the data though. Like if you have different kinds of data, different sets, like let's say you created a model with one set of data, like Excel file or somehow, and then you get a new set of data with totally different like images.
Sure.
How do you have to totally shift the model you choose, or how do you go back to it?
You don't shift the model. So this is a live example. Okay, so this is a live example. This is for a cell phone company we done. So the cell phone company is basically, if you're on a 2 GB data plan, before your data plan expires, not the voice plan, data plan. So if we are going to consume very quickly, we want to upgrade it to a different plan and bill you separately. Okay. So you see this one, it's a live data. Every 60 minutes, we get data. Every 30 minutes, we get this data, connection data. The moment you connect a cell phone, let's say I'm talking to you, we both are talking on a cell phone. The moment I connect, that connection data I get in every 30 minutes, in 60 minutes. That's 1 GB amount of data, okay? So if you have 1 million subscriber, that 1 million subscriber data comes in every 60 minutes and it's 1 GB, just the connection. So these two people got connected. So like this, So in a live system, we don't use Excel spreadsheet at all. Okay, in a live system, no Excel spreadsheet. That is only for learning. So in a live real world experience, you deal with such a large complex data sets. So we have a place for the model to be trained, a place for model to be deployed, a place for model to be deployed and monitored continuously. Let's take an example, what we are trying to monitor. If in a cell phone data plan, okay, a customer, okay, a network carrier has 1 million subscription. Out of 1 million subscription, we want to monitor the system, the usage, okay, the data usage, and the moment we got to know it reached the threshold, we want to send them a plan. So that is the production. In the production, the model will continue to run and predict based on the usage. Okay, let's say you are constantly downloading video. Out of 2 GB, you already lost 0.7 GB. Okay, you left with 1.3 GB, and you have 3 more weeks to go. So we constantly monitor. In the current speed, you will churn out in next 2 weeks. What we want to do, so we want to send a different plan so that you get more data plan. Instead of 2 GB, now we are giving 4 GB. In this case, what I'm describing, the model runs on a live data. When I say live data, the moment you start your data transmission, it tracks you, it predicts you. So answer to your question, the training testing model can happen outside. The production is a live data. And this is the amount of data that we deal. We really don't use any Excel spreadsheets.
Okay, my question is more on how you detect the data out of those. Let's say you have a lot of different systems coming in, and those are the sources for your data, and you're putting into like big data or something.
No question. So this is like you see here, I have connection, I have usage data, volume, DPI, and financial, all this driven based on a problem statement. Okay, you see a problem statement here. So what the companies want to do. So the company wanted to predict customer usage churn. Who's going to churn when, why? So how do we predict this one? So that's based on the problem statement, not on the model side. Once I have this one, the second is micro segment. Why the customer usage is going to churn out? Because it's low usage or a high customer service call, secondary, whatever, correct? So like this is what dictates what data we need. So identifying data and the characteristics of data, the level of detail of data, it's based on the problem that what you're talking.
Okay, thank you.
No problem. So I know I kind of jumped on here and there, so let me go back. Any other questions?
Yeah, actually I have 2 questions. Sorry, this is Divya.
It's only 2 questions, Zaf.
One is like I had it when you were explaining about the building blocks, about the machine learning and deep learning, where you say that simple data set we use for machine learning, and when you have to dive deeper, solve or learn about a complex solution, then we have complex data sets and deep learning. My question here is like, how do you define if it is simple or complex? Like you said, if we don't have a hypothesis, like when you explained to another
So let me ask you this question. Do you mind what kind of job you do?
I was an ERP consultant earlier, but not now.
No, that's fine. And is it an SAP or was it an SAP or what kind of ERP it is?
I'm a PeopleSoft consultant.
Okay, so let's take an example, PeopleSoft, correct? So in PeopleSoft, correct, like let's take an example. So there are so many different things you could do. So one is building a model which allows you to do forecasting on labor rate. So when I say labor rate, starting from month of January in 2021, the labor rate, average labor cost is going to go up. So now I want to build a financial model. Let's assume that the PeopleSoft is implemented in a global scale. When I say global scale, it's worldwide. Okay. So now you are trying to build a simple financial model based on the labor rate increase. What is my expected payroll increase? Right now, my payroll is 100 million in a month. If the labor rate goes, let's assume goes by different city and region, correct? It is not a flat structure. San Jose may have a higher pay rate. Sacramento have a low pay rate. And Atlanta may have a different pay rate, correct? So compared to all, I want to build a financial model which tells me based on the labor increase, correct? I wanted to tell what is the payroll increased cost. do you see it's a simple or a complex problem?
Because it's global, yeah, I feel it's a little complex.
So what makes you feel it complex?
Because of different regions.
Excellent.
Yeah.
Yeah, so we are talking about, it is not how many employees you have, it's about different regions, correct? So it is basically, Atlanta could be in a different market, and that goes by industry. So some industry may have different rates, okay? The labor units are rate. So by reading the problem, you will understand whether it's a simple or complex. That I don't think we need any training, correct? So we can understand by looking at the problem, whether it's simple or complex, we can figure this out.
Oh yeah, I'm not asking about like how do we. You said the machine itself.
No. I'm coming there. Correct. Okay. So in this case, the problem that what we described. Okay, we want to do a financial model. Ask the machine to predict what is the, because right now we are in the month of September 2020. We still have 3 more months to go. October, November, December. The new labor rate effective from January 2021. Okay, I want to do a prediction, a simple prediction of two things. One is, what is the increased labor rate? So increased labor rate is nothing but a predictive model. Okay, so based on the increased rate, we are not sure at this point. In some cases we know, some cases we don't know. Okay, so we want the model, we want to build a predictive model which is going to predict and tell. So what is going to be our overall payroll cost? Is it going to be 110 million or it's going to be 115 million? I want to predict this one, point one. Point two, I also want to predict by state. Point three, I also want to predict by city. Point four, I also want to predict by the location. So I want to get to each of the location and see what is my labor model. Okay, what is my labor model is going to look like. So do you think this problem is simple or complex?
Complex.
Exactly. So to like, how you as a human saying it's complex, the same for a machine too, right? The machine also feels it's complex. If it is complex, then go for deep learning. Okay, if it is complex, why? Complex in nature, the approach to take and solve this problem is complex. So we were talking about country, which is global scale, then the state, next level, then the city, then the location. We were talking about doing forecast at a various level and various data points. The data points are, labor rate could be different for a restaurant worker, labor could be different for a truck driver, labor rate could be different for like software engineer. So all these are all different labor rates. So using this and coming up with a model where we can incorporate that in PeopleSoft, where PeopleSoft have a report, any company who want to do financial forecast for increased labor rate, run the reports. They will give you this one. The underlying is in a deep learning model. The deep learning model takes all these different data points and also inputs such as what is the labor rate, what's the job title, what's the labor condition, etc., and comes back and tells you. So I think by looking at the problem, analyzing problem, you will know the complexity, the level of data that is required, and based on that, you can decide which model to choose. So I think it comes by experience. It's not a scientific answer, do this and do that.
Okay. And the other question is like, when you said the machine has to self-learn, like
Sure.
you were explaining about why we say that it's instructional based or self-learning.
Sure.
Is there anything like we have the algorithms behind where we say that if we have these problems already, we have the data sets and we define these are the things that.
Answer is yes. Answer is yes. Look, that's called pre-trained models, right? Like, so if you see, so what I'm talking about, so these are all pre-trained models. Okay, so the model that what you're looking at, so I don't have to build everything from the scratch. Okay, so all I have is, I want to create a architecture blueprint for a civil engineer. Okay, so what do you call? It's called building profile, correct? So what do you call this one? Building profile. So this is, okay, so I want to create a building profile. You give me the number of square feet, I will give you back an architectural framework. Okay, so what does it mean? In a 2,500 square feet, how many windows I have to have, how many doors I have to have, and what is the roof ceiling height? Like this, I want to come up with an architectural plan. So based on my prior experience. So in this case, the model is already trained. This is called pre-trained model. So you don't have to do this one.
Okay. So what if the model doesn't have a scenario where?
So then we have to build one.
Okay. Okay.
Yeah, then we have to build one.
Okay. Thank you.
No problem.
Keith
All right.
had one question. So I think she's trying to unmute, but she's not able to. Keithna, can you try once again to unmute yourself? Okay, seems like we have some issues.
Hi, can you hear me?
Yeah,
Yes,
yeah.
we can hear you now.
Hi, yeah, this is Deepthi. I wanted to ask the question regarding data cleaning. So, as you mentioned earlier, there were 3 steps like select data, run model, and then the outcome. So in the select data, so we are just uploading the data set. So how does the data cleaning or data augmentation in terms of image data set happens in the background? And do we use the inbuilt library in the Python itself, or are there any different methods to doing that?
So answer, it has both. So for example, the example that I was talking about here actually, so if you look at, this is the model we built for time series forecasting, time series analysis, correct? So why does my sales is declining? Is it seasonal? Is it irregularity? It's cyclic, correct? This is how it happens in the month, correct? So in this case, if you see here, one of the section, I have import required libraries. So I use pandas, which is data framework. And I use NumPy to store all the images in a large arrays. Scikit-learn, it's for the machine learning models, correct? Like this, I do use pandas, correct? That is one. Can you keep your phone? All right. So we do use pandas, that is for processing data. So going back to your other question, I don't want to run ETL process, correct? I don't want to hire ETL developers run this one. How could I teach the machine apply certain rules on data? So that more of data cleansing through machine learning. So that also we use models. So we use clusterings, hierarchical data analysis, dimensionality reduction, language modeling, etc. Example, if I see duplicate record, I want to remove them. If I see an incorrect data, so one of the things I told you, I know my GL account is 9 digit, but I have only 6 digits. I'm missing 3 digits. How do I fix? Okay? So those things are done by here, not through Python. Okay. Answer to your question, we use both. We use Python library, the Python data frame, and also machine learning models to clean the data.
Okay, got it. Thank you.
No problem.
There was one question she's not able to actually talk. Let me ask that. It's in the question Q&A. She's asking, this is really informative. I mean, I have a question about the cash register example. The Excel that you mentioned will work as a model, but the logic that amount returned is difference between amount given by customer and price charged for food the customer bought. How does the machine knows this logic? Does the machine learn the pattern based on model?
Yes, it learns better, not the model based on the data, what it sees in the data, correct? Like, so when I say item that ordered, whether it's billed correctly or not, so the first step is teach the machine about what product you are selling, it understand. And for each of the product, what's the price, it understand that one. Once it understand, when you give a test data, when you give a real data, it tells you for this product, what is the price. So let's say some of the product may also have an extra add-on, correct? I do like tandoori chicken, but I want to add, like on top of the tandoori chicken, few flavors. And those flavors may cost more. So there could be an added charge. So based on the item you chose, the first step is to train the machine to understand the pricing model. Once that is understood, then our second step is, okay, how does the machine knows what you are giving us an input? How you are giving us an input, that matters. Giving your input, either it could be in a receipt as an image, or receipt could be a data, correct? Not an image, is a data. So then the machine will be trained to learn and understand the receipt, what you are giving to the machine. So it's a set of sequence of process. It is not just like one process where you can go and just do this and do that. So If the data sitting in an Excel file, can I use an Excel file? Yes, you can, not a problem. But the example cast register, what she was talking about, I don't think we can use an Excel file. So it most likely is going to be an image recognition. It understands the image such as receipts, such as a cash bills, then it figures out from there. Or if a menu card, so you give a menu card, the machine reads and understand each item in the menu card and detect the pricing. So that is possible, correct? So I'm sure you have heard about it. The most common example people talk about in YouTube's gender detection, detecting whether it's a male or female. You give an image, the machine detects and tells it's a male or a female. You give an image, it tells the age group, whether the person is 30 years or 40 years or 50 years and etc. Or you can give an image, the machine tells whether it's an Indian, Chinese, black or white, whatever. Like this, in the same way, you can give a receipt, the machine can scan and tell you. That may not be the right way to do. So there may be many different options. Answer is, to building such automation, it's going to take some time, okay? But it's doable. You can give input an Excel spreadsheet or an image or in any form. That doesn't matter.
Okay, so there is one more question. It's how do I make my kids to eat? So Madhavi, we would have to create artificial intelligence for that as well, I think. So we should all, as mom, think about that. All right, Keetna has one more question. She says, I would also want to know if you had an opportunity to work on investment predictive model.
Right now, I'm working on a project which is more of lead profiling. Lead profiling means, so let's say you're a Walmart, okay, or a Costco. There's hundreds of customers coming to Costco and telling, I want this product, I want that product, I need this, I need that. So if you look at on a global scale, on nation level, on a daily basis, they get about 50,000 leads like this, okay? So ultimate goal is what? Sell these products. To sell this product, I need to prioritize which one I can go after, correct? Obviously, I cannot go all the 50,000. So we have qualification. Out of all the application or all the lead that what we got, what is the top 10 lead that I'm going to chase? Similarly, we could build a model, okay? We could build a model, where to make investment, where to not make an investment, okay? As I said, whatever you think, all possible, but it's not easy. It's going to take a lot of time, a lot of energy, okay? So to simplify, yes, we can build investment model. I have not built an investment model in my job, but I have done in a model which profiles the leads. So when I say lead, if 100 candidates are applying for a position or an opportunity, out of all the 100 candidates, what are the top 10 candidates? Okay? So in my example, it is not candidate. It's more for when you are requesting someone to service you, the company who's going to service you, if they get hundreds of thousands of leads, out of this, which one I'm going to qualify and why I'm qualifying this. That's the kind of work I did. But technically it is possible. We can do that.
I have one more question. Like, do you have any model strategized for agricultural, like artificial intelligence?
No, I don't have one, but there are companies that are doing this one. So I don't focus on agricultural. So my focus more on health, energy, consumer, oil and gas.
Okay, but is there an option for agriculture too?
Like I said, anything can be done. Take my word, anything. Okay, anything can be done. It's not only agricultural. Anything can be done. Okay. Anything.
I think initially you were saying like you will be questioning. Now we are stumping with our question, I believe. So sorry.
That's fine. I'm not able to move forward. Actually, that's why my questions are limited.
Sorry.
That's fine. It's fine.
I'm having a question actually. So talking about large data volumes, so are you attaching the personal identity with the data, or how do you deal about data privacy?
It's a good question. Let's take an example. I have a video. So in the video, let's take, there are 100 characters, okay? 100 characters. So the person who came on frame 1, again comes on frame 100. So between all this other 99 frame, this person never came. So when I detect across the frame, correct? Not just only one frame. Yes, we identify and assign personal tag for each of those entity. As I said, you're watching a movie, so you want to count which character came the most or which character played a dominant role. So without watching the entire video, I want to build a model which tells me in this video, these are the 20 characters, summarization, out of this 20 character, this character played very dominant role. So how do we do this? We use facial recognition, object detection, assignments. So we assign personalized tags for each of those one and then process from there. So the moment we see an object or an image or a human, whatever, we assign our own tag and take it from there to run the entire process and process them. Any questions further?
Yeah, thank you.
But again, all these things are all, yes, all these things are all, it's not that easy. It's easy to say. It's quite, that's why I said it's advanced computing. This level of computing is not that easy.
Yeah, it's also a wow part and also a scary part. Both of them is there in the AI, I think.
Yeah.
Yeah, I think the modelers who are designing it now should handle the human part also, like kindness.
Yes,
They
yes.
should add some kindness to it. Yeah.
Yeah, definitely. All right. Okay, I think let's move on. So we do need to take a break. Kaushal, yes, Kaushalya. What's your question, Kaushalya? Can you
go ahead, Kaushalya. I am unmuted you.
First of all, thank you so much for giving us this great of an exercise here. My question is towards data science. Data model, and you provide your solution saying like this is the greatest accurate model, right? How would you?
Your voice is breaking. Your voice is breaking.
Hear me well now?
I think so. That's fine. Let's try.
Maybe you can type the question, Kaushalya.
I'll try once. If that doesn't work, I'll type the question. So my question is towards data science. So you come across with a model, and depending on its accuracy, you project your model, right? But how would you convince the stakeholders that this is the best model and these are the best results?
Sure. Okay, it's an excellent question. Okay, so the convincing stakeholders based on the model outcome, prediction accuracy, and then the confidence level, and then the weightage. Let me give you one example. Correct. So almost 3-4 months back, I was in the project. So in the same project, one of the large consulting firm was there. So like what you said, for the same reason, I got involved. So they were trying to predict a customer churn, which customer is going to churn, and that's all they did. So they didn't tell why the customer is going to churn and what is the reason behind. If you have 20 reasons, which reason has the highest weightage? Okay, so that is basically my job. So all they did, the previous company that I'm talking about, they ran a model and gave a report. Out of all this 1 million customer, this 2% of the customer is going to churn out. They didn't tell when, they didn't tell why, they didn't tell the reason, they didn't tell if there is a multiple reason, which reason has the highest weightage. And that's what I did. So this is part of model implementation. When you run a model, you can't find out the probability of an occurrence. Okay. So what is the confidence level in the model it predicts, and what is the accuracy? Number one. Number two, if the expected outcome has a reason to justify, and those reasons are multiple, then tell, let's say the customer is going to churn out because the price increase, or because quality, because customer service, because in terms of payments, etc., payment flexibility, etc. These are the reasons. Out of these 10 reasons, the number one reason the customer is going to churn out, price increase. The number two reason the customer is going to churn out, quality. Why? I want to prevent this customer. I want to stop the customers churning out. So to gain a confidence from a stakeholder or a business, you have to speak their language. You have to provide enough information for them to work on. In my case, I did not just give only a report. I gave them a model outcome, a model prediction accuracy, model confidence level, model prediction reasons, and the reason weightage. And that is my justification. So that's the process I implemented. I hope this helps you.
Thanks, that's me.
All right, let's move on. Then we'll take a break. Okay, so keep your phone in mute. So what we studied so far, correct? We studied about how do we teach the machine. So when you teach the machine, build an intelligence, there are different types of intelligence we can build. Okay, that's also really key to understand. I'm sure some of you may have already seen this one, heard about it, but I don't think that you may have a lot of clarity around this one. So what we're talking about right now, what we are doing right now, including self-driving autonomous car, it's narrow intelligence. Okay, it's very narrow focused. So what we want to do general intelligence, where we want to ultimately land super intelligence. So if we talk in industry as a concept, when people talk about building intelligence artificially, that falls under three groups: a narrow intelligence, a general intelligence, super intelligence. A narrow intelligence, an intelligence basically like, focused on one problem, one solution. I have a problem, I have a solution. General intelligence, one solution, many problem. It solves many problem. You have one solution, many problem. So narrow, one-to-one, one problem, one solution. General, you have one solution that solves many problem. Okay, so let's understand a little bit for these two. What is narrow? What is general intelligence? Let's take an example, the self-driving autonomous car. Where does it fall? That falls under narrow intelligence. Why does it fall under narrow intelligence? So that's because every manufacturer, BMW, Porsche, Lexus, Infiniti, they all build their own autonomous vehicle. They all build their own model. You don't have to. Why? The road condition, the rules in the road are common. It doesn't distinguish between BMW, Porsche, or Lexus, correct? Stop sign, it's common for everybody. Okay, red light, common for everybody. Okay, red light means only for Porsche, not others, correct? It's not that. So the road condition, the environment in the roads are running, the cars are running, it's common. If such, then why are we building separate model for each manufacturer? So that doesn't require. Why can't we build one model which goes across the board? And that's what I said, one solution, many problem. One solution, many problem. So what we have, one-to-one. BMW, their own autonomous vehicle. That means the model which runs inside, it's owned by them. Lexus, it has its own autonomous vehicle. It has its own autonomous model. Porsche, they have their own model and own autonomous vehicle. But the underlying road condition, it's common regardless of whether it's a Porsche or a BMW or a Lexus. Okay, so instead of building this way, we want to build many to one, many problem, one solution. So that is more efficient. Take another example. You go to Amazon.com. So what do you see in Amazon.com? You see a recommendation on the top. Can I take the same recommendation model and put it in Apple Store? Is that going to work? Can anyone answer the question? So you see there is a model in Amazon. So when you go to Amazon.com, when you order a product, it also makes a recommendation. A customer who orders the product, they also order these products. So what is that? That's a product recommendation. So that is based on your previous purchase history and many other factors, it makes a recommendation. Okay, can I take that one? Whatever I see in Amazon. So that's a recommendation. Can the same recommendation model can recommend Apple products, can recommend products in Walmart? Can it recommend product in Target? Is it possible? So that is my question. Okay, can anyone answer, please? So can I take the recommendation engine that what I built in Amazon and deploy them in Walmart or Apple? Can that work? Yes or no?
Yes, it is possible to work, provided it caters to their products that they sell, right?
I need an yes or no. I don't need
No, it
explanation.
shouldn't work because it's like personalized and each products are different.
Exactly, exactly, exactly. It will never work. Okay, it will never work. So that is the state we are living. We want to come out that one. We want to build a generic model. That is what? General intelligence. I hope you understand. Okay, so general intelligence, don't personalize. Okay, don't personalize. Build general model. And that is where industry wanted to go next. Okay, right now, all the startup companies, small companies are doing this. But where we wanted to go, build a general model, don't personalize, don't depend on a product, don't depend on a certain data sets, make it generic. All right. What is super intelligence? Super intelligence, like killing a snake. Okay, you don't have to train the machine. In both the cases, in narrow intelligence, general intelligence, you have to train the machine. So ultimately, what we want to achieve If I see a snake, correct, what am I going to do? Either I'm going to kill, or I'm going to make noise, or I'm going to seek some help, or I'm going to run away. Is that a training I took? Did I go to a snake killing training that I took all these things? No, that's my maturity. That's my maturity. It's my emotion. And that is where we wanted to. That's what super intelligence, okay? That's what super intelligence. So I'm not saying this is a projection based on what I've seen. It's from many different sources, factors. So people are saying by 2025, we will reach the general intelligence category. So what it means, a system should work regardless of who you build, what you build. Okay, in a given business context, if it's a recommendation, you should recommend across the board, correct? So let's say an example. In your case, if you're working in Walmart, you understand Walmart products. You can recommend as a sales clerk what when a customer asks a question. So let's say you left Walmart, you go to Apple. You got trained at Apple, now you're making a recommendation in Apple. Now let's say you left Apple, you went to Target. You learn and understand Target, you're recommending something in Target. It's like a human, multitasking, multi-different roles, correct? So based on the context, you are telling different things. Such intelligence we want to build. You can work in Apple, you can work in Walmart, you can work in Target. Based on where you are working, what you are doing, you are making different recommendation. We want the machine to do the same thing. That's the general intelligence that we are hoping we will be reaching that state 2025. By 2030, we are hoping to reach super intelligence, which is basically don't train a machine on a maturity, the machine works by itself. All right, it's all nice to have, that's fine. Let's talk this key topic. And this is a question that's been asked. Again, I'm speaking myself. I'm not speaking for out there. So there are so many people out there, correct? Like, first of all, there is no such things called, oh, this person knows everything, or he or she is guru in AI. That's nonsense, correct? Seriously, correct? You can't be an expert in every space. There's no way one person can be expert in any space. If someone good in model, they may not know data. If somebody good in data, they may not know model. Somebody good in data and model, they may not know business. So somebody good in all, they don't know how to compute, correct? So I'm not saying all the people out there who say I'm a board member, I do this and that, I do all this nonsense, correct? Without knowing any of these things, I was surprised how they're talking about it, correct? They have done any implementation, correct? Any implementation. So what I'm speaking here, in a real world, when I'm involved in projects, when I do project work, what are the skills I am expected to have to solve these problems? So these are the skills, in my view, it's most critical. Okay, these are the skills, in my view, is more critical. But at the same time, where do I start my journey? Correct? Obviously, this is too much to handle this. Correct? This is not something I'm comfortable. It is too much. Correct? So you have to make that call. You have to make that call. So the area of focus, if you want to build intelligence artificially, it starts from business process. What is the underlying problem you're solving? That is fundamentally most important. If you don't understand, then you don't know how to train and teach the machine. Okay? It's as simple as, if I want to teach my daughter either calculus or linear algebra, I should know calculus and linear algebra. If I don't know, obviously I cannot teach. If I have to teach my daughter or a son how to cook biryani, I should know how to cook mutton biryani. Then I teach them. If I myself don't know how to cook mutton biryani, how could I teach them? That is what business skills are about. So business skills, nothing but whatever problem you're going to take and solve, you should know what this problem and what's the business context of the problem. If you don't know, then you won't be able to teach a machine. So that is how it is. Okay. So the number one, yes. So there's a question from Mahalakshmi. Yes, Mahalakshmi,
Yes.
what's the question?
Yeah, I wanted to know, like, is there a possibility of machines to take over human by any chance? Because you're telling like machines are learning by itself. So we see in some films just wanted
Sure.
to
Like I said, I'm not saying that I know everything, or I'm not saying that I'm the only person who knows this one, but based on what I see here, there will be more machine interaction than less human interaction, right? On our day-to-day life, okay, on our day-to-day life. So there will be more machine type of an interaction than human type of interaction. For example, you can ask yourself, So 10 years before, how many people had a cell phone? Now, how many people have cell phones, correct? So 10 years before, maybe 100 population, 100 people, 1 or 2 people may have cell phone. Now, all 100 have 2 cell phones, correct? How does that possible? That's the market condition. That's a market condition. Let's take another example. 10 years before, how many people went to Facebook? Okay, out of 100 people. So Facebook may not be there, or only 1 or 2 people. Now, out of 100 people, I'm confident 60 to 70% of the people go 2 or 3 times Facebook in a day. What is this? These are all cultural changes. These are all our day-to-day lifestyle changes. So like this, artificial intelligence will become part of our life, such as cell phones, Facebook. So it will become an integral part. In what extent it is going to impact people and employment, etc., that is questionable. Why? We have not clearly understood all the things. So there will be impact, but I'm not saying that it's going to replace a human. That will never happen. But the interaction is going to be less on human, more on a machine. That's how I think.
Okay, thank you. I have another question. You have told like we can teach our kids like that. If we know very well, we can teach our kids. Okay,
Definitely.
we have same level of experience and knowledge, and it is not like every child will be learning the same way what we learn. Is there like in machines also, some machines will learn and something won't learn kind of thing?
Sure.
Like
It's a very good thought. Like, so the way you're thinking is, I really appreciate that. Actually, it's a good thought. So the way the machine learns, it's based on the technique what we chose, correct? Like, the model what we chose, the technique what we chose, correct? So for example, we talked about supervised, unsupervised, reinforcement learning, deep learning, computer vision, etc., etc. Let's say I'm trying to do a facial recognition. That means when Mahalakshmi comes in, I want to recognize this Mahalakshmi and greet her. How are you, Mahalakshmi? Correct? So that is the kind of app I want to build. So this I want to implement through a simple supervised machine learning. This is a hypothetical example. In that case, the machine may not even know. Like, I'm trying to use a simple deep learning model which tries to predict and tells, is Mahalakshmi? Yes. So in that case, the machine may not learn well enough. Why? Because there's a learning limit, like you said. Okay, how much the machine can learn. In that case, I can use a neural net, which is part of deep learning, correct? Which is part of deep learning. I'm sure the neural net is going to predict highest accuracy. So answer is yes. It's controlled based on the type of model you choose and based on the data that you provide and the type of training you provide for the machine. So based on that, the machine can learn and understand. And also each model has its own limitation. How much a model can learn. If it's a very complex data sets, the supervised machine learnings may not work out. In that case, you might use the deep learning models. Answer is yes.
Thank you so much.
All right, so let's move on. So in my view, so what are the skills really required? The number one is a business skill. As I said, if I want to teach my kids to how to cook biryani, I should know how to cook biryani. If I don't know, I don't know. Why do I need to know how to cook biryani? So to make a biryani, what are the things I need? I need rice, I need water, I need salt, I need mint, this, that. So that comes from where? That comes from business. Okay, that comes from business. That doesn't come from model. Okay, so that is basically like one of the questions that asked by what input I give, what output I expect. So that comes from business skills. So the number one skill in my mind, business skills. The second is data engineering. Okay, data engineering. I'm sure most of you or all of you or some of you have heard about database administrator, data architect, and data modeler. All these job titles, okay, data analyst, all the job titles you have heard in your life. But now the new trend is data engineering. Can anyone tell, based on your experience, what is data engineering? Can anyone tell your understanding on what is data engineering? So what we have seen, we have DBA, Oracle Database Administrator. We have data analyst. We have data analyst who can analyze data. We have data modeler. We can model the data, correct? So we have data admin who can administrate the data. So all the title we have heard, we have seen, we have friends who's working in the space, but we may not have heard about data engineering. So before you even go there, I want to understand from your point of view, what is data engineering? Can anyone tell, please? Can anyone tell from your point of view, what is data engineering?
Hi, this is Deepti. Data engineering is basically the combination of software engineering plus data science. So basically, in the data engineer will work on the back end of how the data analyst job will be easier?
Sure, I do agree what you're saying, but I need a clear definition. Okay, I know you're learning, Diti. I appreciate your time. No question, you well said, but I'm looking for something very clear.
So having a skill set of both an analyst and an engineering technical skill together.
You touched some of the points. Okay, it's a very simple. Thank you so much. I really appreciate all the times and effort. Awesome. So
Kirtana also had some answer. You can.
Yes, Kirtana, go ahead. Go ahead, Kirtana. Kirtana, are you there?
Yeah, Kirtana cannot talk. She said slicing and dicing of data.
Okay.
And providing the data in a format that the model can understand.
Okay. Yes, so that is definitely the case. All right, let's move on. If no one is ready to answer. It's very simple. All I can tell, what an engineer will do, what a civil engineer will do. A civil engineer, a construction or make a building available. What a mechanical engineer will do, make an equipment and a machinery available. For what? To do something. Okay, it's a production. It's a production. A civil engineer constructs building and make building available. A mechanical engineer constructs equipment or a machinery, make it available. Same for a data engineer. A data engineer constructs and make the data available. It's called data orchestration. Okay, data orchestration. You apply engineering principle. What is the engineering principle? As I said, a civil engineer construct, make it available. A mechanical engineer construct, make it available. A data engineer construct data and make it available. Why in the world it came like that? That's because now data in any form. What form? It could be machine, it could be sensor, it could be structured, it could be unstructured, it could be any form. Okay, it could be any form. I'm looking for a slide to show. So I hope I have the slide. So it could be in any form. Okay, it could be in any form. So when a data is in any form, we have to have a better way to manage and process the data. So I don't have that slide. So that is the reason what we have to have a process in place to do this one. So anyway, the next key skill in order for us to work in artificial intelligence, data engineering. Okay. The reason why we have engineering, make data available for the model to run. Make data available for the model to run. How do we make the data available for the model to run? You collect, prepare, provision. You collect the data, prepare the data, provision the data. How could I do? It is not simple, writing a simple SQL statement, select star from EMP. It's not that. Okay, it is beyond that. Now we are talking about data in the form of YouTube, data in the form of Twitter, data in the form of a social media, data in the form of Oracle table, data in the form of an Excel spreadsheet, data in the form of an image, a video, voice, or a text. It doesn't matter. It doesn't matter. In whatever format it is, I want to make sure my data is ready. So that's the next skill. The third skill is applying science on data. And this is what we talked at the beginning. Okay, so far, we have not applied scientific technique. Okay, we just know how to write simple SQL statement or write a programming construct and deal with data processing. So now we are getting into a different approach. The approach that is, I want to use statistical data analysis tools, such as decision tree, random forest, linear regression, logistic regression, K-mean clustering. How do I apply on data? That's what modeling skills. That is what modeling skills. Nothing but you have a large complex data sets. I want to understand the pattern. I want to make the machine to learn about the patterns. How can I do? That's what modeling skills, which is strictly model engineering. Okay, model engineering. The next point is cloud computing or anything to deal with advanced level programming, working with GPUs. Correct? If I'm dealing with huge amount of images, my CPU may not work. I have to have pretty intense, complex machines processing data. So it depends on the type of problem you're solving and the infrastructure, what you're going to do. You may end up microservices, writing some microservices. You may end up working on a cloud infrastructure. Okay, you may working with a lot of other libraries like scikit-learn, TensorFlow, Kaffe. Okay, so like this, there are so many different libraries. So these are the core skills really required to become at least a decent, knowledgeable person or a subject matter expert in the space. Where do we start and how do we learn? As I said, if I don't know how to cook biryani, obviously I cannot teach my kids. Correct? My goal is to teach my kids. to cook biryani. Am I knowing cooking biryani? No. So I should learn how to cook biryani. Then I can go and teach this one. So the first step is figuring out what industry you want to specialize: healthcare, retail, oil and gas, energy. So at least understand one or two functions. Okay. Obviously, we can't be master in everything. So one or two functions you can understand and see what you can do in that function using artificial intelligence. Then move on to data skills and modeling skills, or depends on your preference. I want to learn models first, then I can go to data. But these are all very complex interdisciplinary study. Okay, interdisciplinary study. If someone says we'll teach you in 6 months, make you successful, it's absolute bullshit nonsense. Don't go. Okay, that's not going to take you anywhere. It is your own effort. You must have to put your own effort to learn these things. The other people will help you, support you, what they can do. Correct? So there's no clearly different timeline. If you work hard in 6 months, you'll be very comfortable. Correct? But to be a subject matter resource who can speak about artificial intelligence, who can speak about data science, who can speak about intelligent automation, who can speak about digital transformation, in my view, I'm not saying it's everyone's view, in my view, these skills are must. And these skills definitely is going to take some time to learn. It could be 3 months, it could be 6 months, it could be more than that. It's all based on how well we want to get involved. All right. So by doing this, what kind of job you could get? You could focus for becoming a data scientist, that's possible, or data engineer, that's possible, model engineer, that's possible, AI developer, that's also possible, a program manager, that's also possible, overall architect. I can architect the end-to-end solution. That's possible. So these are all different type of roles you could expect. Based on your comfort, based on your expertise and experiences, you can choose any one of these roles. But as a core, you have to understand all the things. Okay? So you have to understand all the things, at least at a decent level. Please keep your phone in mute. Please keep your phone in mute. Okay? So this is what we started with. What it takes to become an artificial intelligence subject matter resource, either as a data scientist or a machine learning engineer or a data engineer, advanced computing.
Can you all mute yourself, please? I just allowed you to talk just for the question and answer session. Please mute.
Please keep your phone in mute, please. All right. So this is basically what we started at the beginning. So what it takes to become a subject matter expert. Okay? So these are the core area I would focus. As I said, it is not that easy to start learning one by one. It is going to take a while. It is something that I would suggest to children. Quite possible, but at the same time, it will take time. It will take time, a lot of time, energy, effort to get there. Okay? To get there. The underlying technology, what technology we need to learn, and what are the things we need to learn, I will cover this one later. I do have a slide which talks about it. Okay? But at a high level, if we wanted to become a subject matter resource in the space of artificial intelligence, okay? I hope you understand. Okay? When people talk about machine learning, this slide covers everything. When you say artificial intelligence, it covers all the things. It covers intelligent automation. It covers data science. It covers digital transformation. It covers machine learning. Each one have its own purpose. Each one have its own purpose. If your goal is to get to this level, okay, where you say, I am a professional of artificial intelligence. I understand how artificial intelligence works in business. I understand how I can apply this in a business. If that is the level of confidence you want to build, the expectation is know everything. How do I gain such all the skills? Okay, and that is what I'm talking. So you can, using such skills, build data science, build intelligent automation, build digital transformation, build machine learning models. You can do all of those. Okay, when you do that, these are the jobs you could expect based on your interest and expertise. All right, so that's basically what it is. So before we go on to the next level, we'll take a break. Okay, so I did see some questions. We'll take 1 or 2 questions, then we will come back again. What's the question?
So can you brief us on A/B testing? How much knowledge should a data scientist possess on this skill?
So on a scale of 1 to 100 hours, let's assume I'm a data scientist. I spend 100 hours to build a data science solution. So let's take one example that I talked about, in the prediction of length of stay of a patient. Okay, so I'm building a predictive model, which is basically tells the hospital front desk people, when a patient comes to the hospital, they want to put a number of days the patient is going to stay, which is a length of stay. an average length of stay for this patient. So that's my underlying problem. This problem falls under data science. So let's assume this is a problem I'm going to solve. For this problem, I'm going to implement, let's hypothetically assume simple thing, yeah, random forest. Okay, it's going to tell the length of stay. So let's assume that I'm going to use linear regression, sorry. So it's a very simple, easy. Assume that when the length of stay is going to be 2 to 3 days. That's a range of value, okay? So in that one, I have to spend 100 hours. How much time I'm going to test on the testing side, correct? So the testing, it's not going to be too time consuming, max 10 to 15%. So out of 100 hours, 10 to 15 hours I would spend on testing. Testing, it's basically, it's understanding what the model is doing. It's kind of model analysis. Okay, why the model is not predicting, what combination of data is working well, what combination of data is not working well. Okay, so that is how it is in my case. It could be different. Can anyone tell, I have a common question, okay? Can anyone tell why the job title is called data scientist? Okay, why does the job title called data scientist? Why can't be something else? Why does it's called data scientist?
Because you're trying to discover something based on the pattern. It's not something really available, right?
Exactly. So you do trial and error, exploration, exploitation. Okay, exploration and exploitation. You don't have a clearly defined answer until you arrive the state. You continue to try different option. What is that option? Under what data set the model works well? So example that I gave you, okay, I'm predicting length of stay. In the first attempt, I just used only clinical data, behavioral data. The model, the accuracy of the model is not that good. Then the next case I implemented using the patient demographic information and also patient lifestyle and fitness information. Now the model accuracy is increased actually. Okay? So you try with all different combination arrive state. That is where my time has been spent. So using different combination of data sets and analyzing the model and arriving a state. So my time has been spent out of 100 hours. I would say the time I spent on data on model analysis and model engineering, model analysis, I would say around 70% of my time has been spent. The remaining 60% of the time is one different thing. Out of this one, how much time I'm going to spend on testing? 15 to maybe 10 to 15%, that's it. I don't spend too much time on testing. I know when the models doesn't work well, then I know what to do at that point. Any other questions?
Yeah, one more question about the, what to say, yeah, what is the fifth skill? The previous slide showed only 4 skills.
Yes, this covers everything. There's no fifth skill in my books.
No, I think she got confused. I'm not very sure about that. So only 4 skills. I think you got the answer. Okay, how about, so one more question, if I don't know if you answered this, it's a very old question that I see. They are asking if the coding is required or not.
Answer is yes. Based on what level you want to go. So if you want to go as a program manager, project manager, product manager, you may not have to code. Okay. If you fall under any of these roles, data scientist, you must have to code. Data engineer, you must have to code. Model engineer, you must have to code. Again, I want you to understand, I'm not coding business rules. I am coding to train the model. Okay. I'm coding to train the model. I'm coding to build model pipeline. I'm coding to do model analysis. My coding is not doing business validations, business rules. You see the entire code block, not even one line written about time series analysis, time series forecast, correct? Nothing. So all it is doing, how do we train? How do we test? How do we validate? How do we deploy the model? That's all I'm doing, correct? So answer to your question based on your career objective, where you want it to be. So if you want to be a manager, so in that case, you may not expect to code. If you want any one of these roles, such as a data scientist, data engineer, model engineer, developer, programmer, whatever you call, or an architect, this all expected some level of coding required. And that coding, it's more around model, not on a business process. In the current state, we focus on a business process, not on a model. Any other questions?
Yes. Is there a Can I go ahead?
Yeah.
Thank you. Is there an open source repo for the AI algorithms or a community source?
There's so many. There's so many. There's the best one that I like, Baco. So you don't even really need to worry about too much about the underlying complexity technology. You can quickly build a model. So they provide interface. You can use that one. So that one has then the TensorFlow playground. So that's one of the awesome area. You can learn a lot. It's called TensorFlow Playground. Wacko.
Can you spell it?
I will send you an email. Okay, I'll put it in the chat window, both of them.
Oh, thank
so
you.
that's a good start. That's open source. That really provides an end-to-end all the things what you need from data to model to everything. That's a good
Do you
start.
think those algorithms will be curated, or like, you know, we have to go through our own like scrutiny of
That's a framework. That's a framework that gives you, let's say, if you have to go and build everything by yourself, like what I have here, you see this one? It's a code that we wrote, correct? In this one, we have a configuration, an INI file. The second is import the required library. And third is import the training data. The next is import the model. Then the trained data. So this complexity coding not required in those tools. It's already there. You can use them. Wacko already has this one. Have you heard about AWS SageMaker?
No.
Okay, it's similar to that kind of tool. That's a licensed product, so it's not an open source. SageMaker is a licensed product. It's similar to that. You can use those kind of tools. What I'm saying actually, I would suggest learn this way so that you can understand the intricacies, correct, how it works. So if you use any pre-trained model or the things that already readily available, you don't understand the intricacies. Then if this doesn't work, then you run into problems.
Okay. Instead of like the models itself, or those algorithms available that we can plug in and play with,
That's what I'm
customize.
saying. It's already available, correct? Like for example, in SAP, one I was talking about, correct? So this particular tool that I'm talking, correct? So you see here, SAP Cloud for Analytics, correct? You see this tool? So this tool has a pre-trained model. For example, I have a classification problem, or I have a regression problem, I have time series problem. They already have that one. So you don't have to code what I'm coding here. You can directly provide your data, it gives you an outcome. Okay. So, but only thing what it is, if the model doesn't perform, you are shooting in the dark. You have no clue what the heck going on there.
True. Yeah. Okay. Thank you.
No problem. All right. Any other questions?
I have two questions.
That's only two.
Sorry. At what stage you will tell the model is ready to implement, like any testing or something?
Yes, definitely. Correct. Like, you see this one, the model validation and acceptance. So that is the one you do. So you have a test data. Okay. So let's say one example, correct? Like, what is your son is going to like Monday, Tuesday, Wednesday, Thursday, Friday. Okay. So Monday to Friday, what kind of food my son or daughter is going to like? So that's basically, I want to run a model which predicts and tells me so that it will be automatically ordered through a restaurant. Okay. That's what I want to do. So it's a subscription-based food service. This is actually an application that I worked on. Okay. So it's a subscription-based food delivery. So you don't have to even order. Okay. The model itself understands what do you like on Monday, what do you like on Tuesday, what do you like on lunch and dinner and etc. Okay. So that was part of Uber Eats. Okay. So let's take that as an example. Okay. Let's take that as an example. In that case, okay, so you know for sure what your son likes in the night for dinner. So let's assume your son on Tuesday likes dosa. The model predicts, oh, your son likes biryani. So you see the accuracy is not right. Okay, accuracy is not right. That's just one example that you're taking. So like this, you have a test data. In the test data, you know what's your expected outcome. Until you reach the expected outcome, you continue to train and test the model, where you use deep learning, whatever model you use, until you reach the accuracy and the confidence level, you continue to perform this function. So this entire process, you see, iterative process, it's going to repeat by itself, correct? So there could be problem in the data. There could be problem in the feature selection. There could be problem in the test data. We need to figure this out. And that is where we all need to come into picture. So the software engineering, what we used, it changed. The software engineering right now expects us to do these kind of tasks, then writing programs, writing codes, testing software, none, correct? So going back to answer to your question, so what extent I will continue to do this work until I reach the desired outcome. The desired outcome, my son, Monday night likes idli, Tuesday night like dosa, Wednesday like biryani. Like this, you have a predefined set of test criteria. Until the model reaches the test criteria, you continue to rebuild this whole thing. And that is when you see, yes, I got my desired outcome. It's ready for deployment.
Okay, thank you. That is for the ones which we have already, we are having a set of data which we can ask. But if we are building a new model, you said like everything will be available. If something is not available, we have to build it. So for building a new one, how we will validate?
Sure. So I think you're getting confused one point. So new model, by definition, new model is nothing but the model is not deployed in a production. Okay. So the model is not running in production. Those are all considered to be either a model in development or a new model. So the testing I'm talking about, it's for the new model. So let's assume your model predicts or meets your expected outcome. That model should be deployed in the production. It works in the production. Okay. There also you continue to monitor. So that model, you may not have to train and test on the data that what you're using. So the new model, when you say new model, by definition, new model is nothing but the model either is under development or under design. So those are all new model. Once the model is deployed in a production, that works on a production data. So the new model is where you train, you adjust, you make recommendations and arrive at states until you hit the desired outcome. Does that make sense?
Yes, thank you.
No problem.
I have a quick question. This is Shalini here, Jyoti.
Yes,
so how do we, so for testing the data, right, for testing, how is it provided? Let's say I have data from multiple sources. So is it necessary to provide from all the sources? Because one could be Excel, one could be video, image.
Yeah. Answer is yes. That is what makes this data engineering very core. Okay. That is what makes data engineering very core.
And the other question related to that I have is how much data approximately do we send to train the system?
Sure. I do have slides to cover this one, but answer this question 70-30, 80-20. Let's say I'm trying to, let's assume hypothetically, I'm trying to make a recommendation. When a customer comes to my restaurant, I want to make a recommendation. Before the customer places an order, I will give a recommended menu item for a customer. Okay. So that is the model we are trying to build. So in that one, to train the model, I took 1 million customers. So I'm going to take 1 million customer who placed order for the last 5 years. Okay. So the last 5 years, I have 1 million customer and 5 years worth of data. In this one, out of this 1 million record, 1 into 5 million record, correct? So each year, 1 million, 5 year, 5 million. Out of the 5 million, what is the ratio that I will be using for training and testing? So these are all my past customers, correct? So in this one, option 1, 70-30. So take 70% of the customer, train them. So that is 700,000 customer data will be used for training. The remaining 300,000 customer used for testing. See how the model is behaving. The accuracy is still low. The confidence level is not working. So model is not predicting. It's a lot of problems. Then I'm going to increase 80-20. 800,000 customer for training, 20,000 customer for testing. So the ratio of dividing training data and testing data varies based on how well the model behaves. The second part of your question, if data comes from multiple sources, let's take an example. The customer also writes feedback about on a Facebook. Okay. So a customer who's coming an order, place an order on your restaurant as a one source where you collect what a customer ordered for every day, you collect for a year, then it become historical data. Let's say there are data that you could gain from outside. The customer also has a social media account, such as Facebook. They go there and post an ad. Awesome. I had the biryani. It's wonderful. I enjoyed it. Correct. So you could use that also as a pattern, what the customer liked, when it was posted, and what was the circumstances, what was the events. Correct. So like this, you have data comes from two different sources. One is your CRM system, where the customer information. Second is the transaction system, that could be SAP, what the customer ordered, what much they placed in. And third one could be Facebook. So the key in this case, how do you combine all three and make your training data? That is the biggest challenge. And that is what I said. This doesn't come from either a PhD or from a top school. This comes only from industry. Without this, the model is useless. Model is not going to do anything, right? So that is the reason we talked at the beginning. The key critical skill, so all this make it work. All this make it work. The key critical skill in this case, data engineering, okay? Without data engineering, this won't be useful. So Shalini, to answer your question, if data coming from multiple sources, so you have to make sure you connect and provide the data. So that is the reason I said a data engineering skill, nothing but making data available for the model to run. So it's an engineering principle, such as a civil engineer make building and available for public to use. A mechanical engineer make an equipment or a machinery and available for others to use. Similarly, a data engineer make the data available regardless of source, structure, format, frequency, and model to use. That's by definition what it is. I hope I answered your question, Shalini.
Yeah, thank you.
All right. 2 other questions. What is that?
Jyoti, you need a break actually. You're
Yeah.
so
Yes,
maybe
definitely.
have some
Like,
water break. We've
yes.
been talking for a long time, so we
Yes.
want.
So let's take a break at it's a 3:30 p.m. PST. Let's take maybe 10 minutes break. We'll be back by 3:40 or 3:45. Let's meet at 3:45.
Yes. Thank you.
All right. Thank you.
So if anyone thinks that your answer has not been answered, I mean, your question has not been answered for a very long time, or you really wanted an answer for something that was being taught today, you can unmute yourself and check here, and I will make sure that that has been answered once Jyoti is back.
Okay.
Hi, this is Deepa.
Hi. Hi, Deepa.
I kind of joined late. Are you recording this webinar?
Yes, we are recording the webinar, and we are also going live in our YouTube channel. I have shared in the chat window. You could go there and as well see it there. And then the afternoon session, we are fully going live in the YouTube channel because there was more request.
This is Deepa.
Yeah. Hi, Deepa.
I kind of joined late. Are you recording this webinar?
Yes, we are. I think somebody opened the YouTube chat, so you just mute yourself. And yes, this Deepa, I think your answer is yes, we are recording.
Hi, this is Kasturi. Hey, Mr. Jyoti mentioned about 2 open source items where we could find the models. Is it possible to post those sites in the chat window?
He said he will do so. We will ask him to post it. Yes.
Okay, thank you.
Yamini, I don't think the session will be extending unless and until if you have any other questions. If people have some questions, he might want to answer. Otherwise, Jyoti has said he would try to restrict the timing because there is another session tomorrow. So, and he's been talking from morning. So definitely
Correct.
the session will end on time, hopefully, if you're all not having any questions, any more questions.
No, I mean, so from 3:45 to 4, the session should end, you mean?
No, we are all talking about PST, right? So we still have time.
I'm sorry. So how much time is left? I believe it's
I would have to check that once he comes, maybe we can ask him. Okay.
Yeah, thank you.
Hello, can you hear me?
Anyway, it's till 8 EST, right? So we still have time. You are from which time zone?
EST actually.
Yeah, we still have time.
Okay.
Hi, Meena. This is Kavyashree.
Yeah.
Actually, I would like. Actually, I'm not doing any sort of a job in this field. So I want to learn something. So, what software I could learn for this for this artificial intelligence, or for my son, what language can I suggest him to learn for the beginning?
Okay, definitely he can answer this question. But as far as I know, when before even we had the summer workshop for kids, what the prerequisites was to learn Python by Jyoti.
Okay.
So to get into this, he was asking kids to learn Python. That is
Okay.
what I know, but he can give you a better answer. Let us ask once he comes in.
Yeah, thank you so much. Thank you so much.
Sure.
Hello, can you hear me?
Is it a break?
Yeah. We are Jyoti. Jyoti has gone on a break, so he'll come back another maybe 5 minutes.
Yeah. We'll meet at 3:45. So maybe in next 7 minutes.
Sure.
So how many minutes? Sorry.
Another 7 minutes.
7 minutes.
Okay, thank you. Thank you.
Do anyone want to share their thoughts, like any new, very, very new to AI, and no knowledge about software? How do you, somebody wants to talk about how you feel about
Yes,
this?
definitely we want to hear this one. It's like, because we are talking based on what we understood, and we also want to listen from the audience, like how they feel about it. Can someone talk, please?
Hi, this is Vasanthi from Canada. Actually, can you guys hear me?
Yes.
Yes, we can.
Yeah, actually, I'm working as a quality assurance analyst, and I got so much interest with this data science and a few other stuff. But it has been a challenge, like where to start and how and that kind of a thing. But this session is giving me some good ideas, like how to do, and now I'm getting more confidence that okay, this is the field I really want to explore more and want to switch from my quality assurance to this. It's really helpful.
Thank you. I just want to comment one thing. So when you say quality assurance, correct? Either you do functional testing or you do automated testing, you are doing some kind of a quality assurance, correct? You're making sure the product or a service meets the standards, meets the guidelines, meets whatever you are trying to do, correct? I apologize. I'm not trying to scare you. I'm not trying to say that like this is how it's going to be. Such things may not needed in the future. Okay.
Yeah.
Those things are all easily replaceable. Anything you think it's repetitive task. That's something that you repeat by yourself, like either by week or a month. Those tasks are easily automatable using machine learning, correct? So like I was talking about creating a balance sheet. That's an accountant job. It is complex, but it's not rocket science, correct? When people are getting to automate accounting job, people typically go for CPA or chartered accountant to become an accounting expert. Such rules are automated. Such rules are taught to machine. Why can't we do testing? Correct? So I would suggest learn alternate skills and become an expert in AI or some of those areas. Do not stay in just the testing or QA, whatever it is.
True, I agree with you because now I'm feeling like I'm feeling kind of more saturated because I know I do a good expert on automation and other things, but I feel like I'm really missing something. This is not going to go for a long time and that kind of a thing. So I always love working on data migration or anything related to data. That's why I just concentrated on exploring more new information related to AI and data science and all. Yeah. Now this workshop really helps me to, move in the right direction, really helpful. And we are looking forward to get more help kind of, formatting some WhatsApp group or something like that. I know like I'm living in Canada, so I don't know whether you guys are already doing that or anything, but I'm in Calgary, so we don't have these kind of things here. We have our Tamil Changam, but not doing extensively like US or Toronto or some other popular cities. So this is really good opportunity. So being from some, from India, and it's always good to communicate. And if we get some contact from experts so that we can reach them for any help or anything. And also I'm curious, if I switch the line, how are the opportunities are going to be? Is it going to be harder, or how it's going to welcome my change or career change or anything?
So based on what I know, I can share. In terms of opportunity, what it is right now, the market has not reached its maturity state. So that means people are trying it out, but not in a full scale. So companies are also scared. Companies are also not sure how this is going to work. Companies also don't have enough expertise. So you may not see a lot of opportunity at the moment, but ultimately, as I told you, so if you look at cell phones, 10 years before, if 100 people are there, out of 100, maybe like few people have cell phones, like 3, 4, 5 people. But if you look at all 100 have 3 phones, so things will change. The timing may not be right. You may not be able to find right away what you're looking for. But if you're on the track, you will get something out of this one for sure. For sure.
Yeah, that would be nice. Thanks.
No problem. Anybody else?
I have one question. Is there like for quality analyst in AI, there will be some quality testing.
So in AI, it's called model validation. Okay, model validation, which is nothing but whatever the model does, you verify that. Like, let's say I'm asking you to make a biryani. Let's assume you made a biryani. How do I know the biryani is good or bad? I have to taste it. When I taste it, I will give my feedback. What do you call? That's called model validation. So whatever you ask the model to do, the model is going to perform. So once the model is performed, that creates an outcome. It's called model outcome. Once the model creates an outcome, you verify the model outcome, which is called model validation. The model validation is nothing but whether the model meets your expectation or not. If it is not, you go back and retrain the model, continue to build the model. So that is how you do it. You don't really have a QA process where you can go and run, set up script and do this and that. It's not there.
Okay, I have another doubt in your explanation.
Okay.
The same biryani can taste different for different people. So how you will end up in validation?
Of course, definitely. So that is what rating does, correct? So let's say there are 10 people are cooking biryani. Out of 10, who's taste well, correct? So how do we define the criteria for it to taste well? So like I was telling you, so one is model prediction accuracy, how well the model is predict. On a scale of 1 to 100, it predicts 99.9% accurate. Confidence level, so at what confidence level it predicts, that's also 100%. So it's just not prediction, it also gives the reasons. Okay, what are the reasons this biryani is so good? This biryani is so good because of the 10, 20 reasons. Out of the 20 reasons, which is the top reason? All matters. So these are all part of model validations. Okay, one is the outcome, second, the confidence level, third, the accuracy, and fourth, the weightage. All this matters.
Okay, thank you so much.
No problem, no problem. So yes.
Well, I have one quick question with respect to the skills that you shared in the previous slide, right? So from the industry perspective, the expectation for an AI professional is to have all the skills because it's all interdisciplinary is what you were saying, right? But some people may not be very good in coding, but other can have a good business skills knowledge. So is the expectation to have a deep knowledge in across all the pillars that you shared?
The answer to your question, this is not a like, do or die situation. Either you have to have or you don't have to have, correct? So this is basically what makes you to be independent. When you are on a project, correct? So you don't want to depend on other people, okay? You don't want to depend on other people. So you can basically do things on of your own. So how could you do things on of your own? So that's coming down to based on the confidence level that you have in all these different areas. So it is not a project requirement. Some are project requirement. If you are, let's assume if you are going for a data scientist. As a data scientist, I would simply say you need all 5 skills, must, okay? Without that skills, you won't be able to really produce anything outcome tangible. Let's assume I'm going as a model engineer. Model engineer works based on only the number 3 bucket in some interaction with the number 2. Okay, so the number 2 and number 3 are the skills for model engineer at a deepest level. Let's say I want to be a project manager. Okay, I don't want to code, I want to be a project manager. If I'm going to that level, what are the skills I need? So you need all the skills at a high level. You need skill 1, 2, 3, 4 at a high level. You don't have to code and you don't have to get into a lot deeper. So this is how you can figure out where you want to focus. Okay? As I said, this is not a project requirement that you have to have all the skills. Having the skills makes you independent. Having the skills make you get done things very fast. These are all interdisciplinary study. Example, so one of the candidate asked me what input I should give, what output I expect. So if I don't know that, I wouldn't be able to answer this one. So when you are in a project, these are the kind of questions we expect. Correct? The end user may not know what model means, what training means, what testing means. So we have to educate them. We have to tell them these are the things we do. In that context, all the skills are matters. Does that make sense?
Yeah. Okay. Got it. Thank you, sir.
Wow. Thank you so much, Jyoti. I was expecting this kind of wording from someone. So I'm basically an agile coach and a trainer. I joined this session exclusively because I'm working for a pharma company where they work on data scientists, like we work with a lot of data scientists where we pull data from different sources, and we do statistical analysis and we do hypotheses to analyze data. Some are math data, some are unmasked data. But I'm as a coach slash project manager, program manager, I don't get into details, but I work with them. And our leadership keeps talking about AI. We have to go AI kind of. And then like this thing came up, and when Meena and Julie sent this, I realized, oh, this is a good timing. So, but I did not come to this session to dive deep into it, to just get an overview so that I can share it with my leadership. After listening to you, it's amazing, mind-blowing that I may get involved into AI, but like I'm struggling. How do I start? Where do I begin? I'm kind of the same as a project manager slash program manager slash agile. I'm an outsider for my team. I just coach, train, and mentor them, but I don't get into technical details. But I may need your help. Where do I begin? How do I equip this so that I can be an AI project manager or AI program manager? So it's amazing. Thank you so much for opening my other side, like where I did not even think of getting into. So I may need your help in that. So we may take it offline or in this, like either way is fine.
Yeah, I think we can take it offline because I have a lot of things to be covered. We can take it. I'm in LinkedIn. You can check me at LinkedIn. You can send me an invite. We'll get connected. We'll go from there. All right.
Thank you. Thank you, Jyoti.
Jyoti?
Yes.
I just want to say one thing. I'm Prema. I'm from Charlotte. I just came here as a panelist. I thought, okay, I'll just come here, sit here for like an hour and leave. But I'm completely a non-IT background. I'm a physical therapist, but I got hooked, the way took the entire session. And besides, I'm a biryani lover too. So I very well. So thank you so much for the awesome session.
Thank you. The reason I used biryani, all these terminologies, it's easy to connect, understand, correct? So what I see here, correct, most cases, people talk about all the statistics, mathematical terms. At a very initial stage, you will get lost, correct? So when you are comfortable, when you understand these things, then it makes sense to go to math and science and talk deeper technical. Until then, it would be something easy, more relevant to use the language what you are quite comfortable. So that's why I'm using biryani. I apologize if that.
I'm a big mutton biryani lover, so thank you.
It's good. After talking about the biryani analogy, I said like when you can talk biryani and AI, I can definitely connect myself with AI. So the confidence boost, like it's boosting the confidence. But you're doing a good job and amazing.
Awesome.
But
Thank
I had
you.
a different intention before coming, and after attending, like I'm thinking that I may get involved too much into AI. But again, I'll touch base with you later.
Sure.
Thank you so much.
No problem. Thank you. I'm not trying to scare anybody, but please don't underestimate or don't think that I'm just throwing something to scare you all. One thing, it has been proven, correct? If you notice, commercially, artificial intelligence has been accepted. Commercially, that means it is not anymore scientific concepts, correct? So things starts from a concept and it evolves and goes from there. So artificial intelligence right now, it's been commercially accepted. Examples, company like Amazon, company like Facebook, company like Google. So these companies are pretty heavily using artificial intelligence, like in many cases. So the finance area that I am trying to demonstrate to you, that's the live project. That's a real project. So what it basically trying to do, every company you go, you have minimum 1 or 2 people working in accounting. All they do at the end of the day, they create financial statements. It could be an income statement, or it could be a balance sheet, or it could be a cash flow, correct? So what industry is trying to do, how do we automate such repetitive, I wouldn't say non-intelligence, a proven matured process using machines, correct? So industries are thinking. So like I said, I may be a good physician, but my skill sets are limited to the knowledge that I gained by working with different cases, or the network that I'm involved, or the journals that I publish, or the friends that I have. But as a machine, I can go beyond. How does a symptom of a cancer disease patient when they have diabetes, correct? Getting into roots of the problem, a machine can go much deeper than anyone could even imagine. So these are all what it means to us, there is a high possibility the machine can do a better job than a human. If such, the market is in such a way, it's kind to look for such solutions. Okay, the market is capitalist market. It's going to drive everything. When it drives towards that, we may have to find something different. And the something different could be artificial intelligence. You could be a subject matter expert, you could be a project manager, you could be a model engineer, you could be a data engineer, or it could be whatever the case may be, correct? So I would say it is absolutely a stepping stone for our future, okay? It is absolutely a stepping stone for our future. We may not jump 100 feet at the same time. It is a small step. Every step is matters. Every step is going to take us to the next step. If you do that, you will get there. I think that is where the world is going right now. Regardless of what jobs we do, whether we are a physician or a nutrition or a hairdresser or a driver, we all have some level of impact of this. And that impact is very positive. But we also need to look, if such things happens, what am I going to do? Where am I going to land? What kind of skill I need? I think that's what these two sessions are. All right.
So for beginners like that, us from non-IT background, how you will suggest to start from scratch? Like what should we learn?
Sure. So the starting point for someone who has never done anything in IT, somebody who has not done any technological work, I would suggest the best place is to, since this involves some level of coding, some level of programming, the best place is, I'm not saying that's the only place, the best place to get started. Learn simple Python script where you can do some statistical modeling, correct? So when I say statistical modeling, right, learn and write simple Python program where you can do standard deviation, calculations around mean mode, like that. It's just a good start, okay? In a longer run, that would help, okay? That's a good start. Second, while doing that, also understand what industry I want to specialize, because this is not common across the board. The moment you say artificial intelligence, where did you apply? That question will come. I applied in healthcare, I applied in retail, I applied in consumer, I applied in energy. Like this, people will ask you. So the second area of focus while you're doing learning Python or some kind of a coding, this is for people who never done any IT jobs, who have never done anything on technology. So for those kind of people I'm talking. The second area for them to focus on an industry practice, correct? Understand something. I know all these are all not that easy, but it's doable. It's doable. When you stay focused, everything will happen. It may take some time, but it will happen. It will happen. So I would say, if I were you, I never done any IT work, I never done any technology work, I want to get into this field. My starting point would be learn and understand Python. How do I learn and understand Python? The first step is download and install Anaconda. So that's one of the package manager, correct? So you see this one, I'm running this notebook. So this is called Anaconda. I can send you the details. You can mail me.
Sorry, I think you're not sharing your screen if you are.
Yes, I am. I am not sharing this time. 1 second. All right, can you see my screen now?
No. Yes. Yeah. Now, yes.
Yeah. So if you want to get started, download and install Anaconda, which is basically one of the integrated development environment. It has most of the component what you need to get started. The second one is the Jupyter Notebook, which comes along with this one. So this is kind of a simple thing for you to practice and understand how a model works from end to end for a given problem. So that would be an ideal place to get started if you haven't done anything in technology or IT.
Thank you. Jyoti, I had one more question here, slightly more on the business side. So we've seen a lot of exemplars use artificial intelligence, and we have great use cases there. But just wanted to get in your thoughts. How feasible are AI investments for, let's say, small businesses or startups? How viable are they? Because from what I understand, investing in AI requires huge amount of capital and a huge amount of backing as well.
Sure. So answer is yes and no. So for example, correct, like, so I'm going to open and tell you. So give me one thing. So this is basically I'm trying to build, it's my cost model. Okay. So I have a VC meeting. I'm in the final phase. So this is my second round. Okay. So I already have funding. It's my second round. So this is focused on offering a product, okay, for the industries, CPG and retail. CPG stands for consumer packaged goods and retail.
Yeah.
So how much money I'm expecting? Around 2.7 million. So we already had $500,000. So this is in a year time, I'm raising this much money. So what they're asking for what is the product we are offering. So these are the product we are offering. Okay. So answer is, it's all based on many things. Okay. It's all based on many things. So what product you are offering, number one. Number two, who's behind the scene? What are the different technologies that you're using and how it's going to work, right? So the offering is fully on a cloud platform, okay? If you see here, so it's on a full cloud platform. It could be small enterprise or medium enterprise, large enterprise, government, non-profit, educational institution, etc. So what are we trying to do? As I told you, any existing BI reporting or analytics, anything, whatever you name it, for the industry of CPG and retail, we transform them into AI. How? We have pre-trained models, which allows you to get to this quickly, correct? And in terms of technology, how does it work? This is what is going to work, okay? So going back to your question, how difficult to raise this money? I wouldn't say easy, I wouldn't say difficult. It's based on where you stand in terms of your offering and also convincing the customers, okay? So I am almost at the stage, so I'll be get funded next month. So it is working, but it's not easy. It's a lot of time consuming work, a lot of things involved. Does that make sense?
Yeah, I think it does. Thank you.
Yeah. And the cost is broke down like this. Product development, how much time? Sales and marketing, how much time? Business development, travel, operations, right? So that is how we put these things together.
Sure.
All right.
Thank you.
No problem. Thank you.
Hello. I have a question.
Yes.
Sorry for interrupting. So you mentioned about the industry practice, right? So you have to think about an industry practice and stick with it. For now, I'm in pharma, so I'm not sure if I'm going to be in pharma. Next, I may get into finance, right? As an agile coach, I have been switching different domains. So can we not extend the knowledge of one industry to another industry and then perform, or do we have to relearn everything, or what happens if I switch industry?
No. You don't have to relearn anything. Let's take an example, finance, correct? So why I stay very closely in finance. If you look at my LinkedIn, in my career, I worked for KPMG, Ernst & Deloitte, 17-year management consulting, correct? So I heavily focused on finance. Why? Finance is the only function goes across the board, correct? Whether it's oil and gas, you need finance. Energy, you need finance. Pharma, you need finance. Healthcare, you need finance, correct? So I picked finance as my core area of expertise, and I stayed to that. Correct? Okay. I didn't go into any healthcare services. I didn't go to anything on oil and gas geological services. Correct? So I work in all this industry. I kept finance as my focus. So going back to your question, if I move from pharma to, let's say, I'm going to healthcare. So I'm going to join, let's say, I'm going to go join Bristol-Myers Co-op. Okay, I'm in Bristol-Myers Co-op. I'm going to leave Bristol-Myers. I'm going to join, let's say, I'm going to join Blue Shield. So Blue Shield is more of a healthcare services. So in that case, what am I going to do there? So it is really going to be based on two ways to look at this. One is, I'm a project manager. I understand the overall process and flow, how it works. I can manage the show. So there you are not acting as a subject matter expert. The data scientist must have to learn the business side. As a project manager, if I understand the overall process, the framework, how this works, I think that's more than enough. People cannot fool you around. If someone says data validation takes more time than data engineering, that lie. That's not the case. So data engineering is the most time-consuming task compared to data validation, data modeling. Correct? So like this, people can't fool you around. So once you have the framework understanding, I think that would be much easier to manage the show. So for a project manager, I don't think that you need to learn deeper process knowledges. If you understand overall process and high level how it works, it's manageable.
Thank you. Thank you so much.
All right, let's move on. So the next point, what we need to understand, okay, this is also really important. Why does a company want to go and build artificial intelligence, correct? So far what we understood, what is artificial intelligence? Number one, in terms of how that is applied in industry in the form of either in intelligent automation, data science, or digital transformation. And how do we do, or how do we create intelligence artificially teach the machine? How do we teach the machine? There are 5 different techniques: robotic process, natural language processing, computer vision, deep learning, supervised, unsupervised, reinforcement learning. Those are the 5 techniques. All right. So what type of intelligence we can build? Narrow, super, general intelligence. We talked about that one. Right. And then what are the skills required? We looked at that too. Business skills, data skills, modeling skills, computing skills. So now, why does a business want to do this one? Okay. So there are many reasons. Based on my work and interaction with the customers, the number one reason why business want to do this one, increase productivity. What do you mean by increased productivity? I'm not saying we are all like this. When we go to our office, if I'm going at 9 o'clock, coming back at 5 o'clock, between 9 to 5, I go for 3 coffee breaks, 4 restrooms, 5 cell phone calls, correct? So if you look at the time that I'm spending on my productive work, it could be 2 hours or 3 hours. All other time doing other activities such as attending phone calls, meeting, restrooms, tea break, coffee break, this break. So the productivity of a human is less compared to a machine. If it is a machine, the machine can do no coffee, no break, no tea, no phone call, nothing. It does by itself. So the increased productivity is the number one reason why business want to go for using intelligence artificially than a human. All right. The second one, an increased efficiency. When I say increased efficiency, what it means actually, right? So if it's a manual process, you are going to interact with somebody, and that may or may not be an efficient way to solve this problem. Let's say I'm watching television. Okay, I'm watching television. Let's assume the television doesn't have a remote control. Every time if I want to change a channel, I have to go and stand in front of the television and change the channel. So that is one way to look at it. Let's say I have a remote control, which allows me to control and manage what channel I want to watch and how much volume I want to keep and reduce, increase. So that's a remote control. So between these two, which one you prefer? Obviously, we prefer a remote control. Why? It's more efficient. So the more automation, become more efficient. The more automation, become more efficient. The second reason why companies want to go for artificial intelligence, it's increase efficiency. Okay, increase efficiency. So they want to increase the efficiency. All right. The third reason why company want to go here, reduce cost. Okay. The third reason is reduce cost. Cost is not always the factor. Cost is obviously a factor, but that's not the factor or the number one factor. So cost will be the third factor why company want to go to artificial intelligence. Let's take an example. Okay, Uber. They're piloting with self-driving cars. That means no driver. You book a Uber, it comes and pick you and drops you, comes back. So in this case, in the current Uber market, the Uber pays the driver, let's assume 60-40. So if you pay $10, $6 goes to the driver, $4 goes to the Uber. Let's assume this car is driving by itself, self-driving autonomous car. So no driver, the $10 goes to directly Uber. So that's basically reduce the cost. Obviously, when the cost goes down, your revenue goes up. Okay, so when your cost goes down, your revenue goes up. In this case, I'm not paying to the Uber driver. That cost, the cost for the driver, it will become my revenue. It will become my revenue. So why does company wanted to do this one? What are the reasons behind? The reasons behind are increasing productivity, increase efficiency, reduce cost, and increase revenue. These are the 5 factors. These are the 5 factors why company wanted to go for artificial intelligence. All right. So you have to consider this one. When you talk to business, why they're doing this one, those are the reasons. All right. So now let's understand. It is not trying to tell you that how much your job is going to impact. Okay, it is not that. I want you to understand the reality. Why? A lot of people don't understand the actual reality. How does it going to change my job? Okay, let's take an example. How artificial intelligence is going to change the job in the software industry. Okay, how artificial intelligence is going to change the jobs in the software industry. Let's look at this one. So a traditional IT job functions, okay, whether you do software testing or you do system monitoring or you do program or project management or you do analyst kind of a job or a programmer, it's all falls under here. You have a problem statement. Okay, you have a problem statement. That problem statement is the one you're going to work on. So that problem statement leading toward creating a functional design, then a technical design, then you code the program, then test it and deploy, monitor and support. Okay, whether you work in SAP or Oracle or whatever technology you work, in all technologies, these are the similar functions you do. Okay, these are the similar functions you do. So here I'm talking about a traditional software engineering. A traditional software engineering involves all these different roles. So these two roles, either a functional analyst or a systems analyst or a business analyst or a technical analyst or someone who's senior systems analyst, etc. So those are the one creating technical design. A programmer, software developer, or a coder will code this one. A QA analyst who's going to test and verify and confirm. A deployment monitor. These are all build and release people whose work on build and release. I am absolutely positive, confident. Anyone who you name in the field of information technology, they fall under any one of this role here. Okay, so what is happening here? They are writing everything in a hard-coded business rules, and we don't want that happen. We don't want that happen. And second, here the problem is all not a self-learning model. When there is a change occurred, you go back and make a change to the software. You go back and make a change to the application, correct? So when there's a change occur, you go back and make a change. So this is a traditional software. When you go to artificial intelligence, these functions are completely changed. I don't have to create a functional design. That functional design became my future engineering. I don't have to create a technical design. That become model planning, model selection, model engineering, data engineering. I don't have to code. That's basically part of model engineering. And model creates a learning algorithm. Then I don't have to test this one and model validation. And that's the questions that many of you asked for. Okay, I don't have to deploy. Okay, the traditional software, it's a model deployment, model monitoring support. So what I'm saying, all the jobs that what we have seen here, in the space of artificial intelligence, it's completely different. Okay, it's completely different. Okay, so here what we are trying to say. So I'm not expected to create a functional design. I'm not expected to create a technical design. I'm not expected to code based on what is written in the functional and technical design. I'm not expected to test what is written in the functional and technical design. I'm not going to deploy anything that like what I do in a traditional way. None of this is required. None of this is required, correct? Why? I am using a different approach. This is traditional software engineering roles, and this is artificial intelligence level role. So if I want to build software, automation, using artificial intelligence, I will follow the one in green color. Why? No hard-coded rule. And second, it's self-learning. This approach is the approach learns by itself. The previous approach, you code everything based on what is seen in this functional spec. You code everything what is seen in a technical spec. And that's a hard-coded rule we are talking about. That's a hard-coded rule we are talking about. This is not self-learning. This is not self-learning. So going back, in the world of artificial intelligence, I don't have a functional spec. I don't have a technical spec. I don't code any business rules. Instead, I use these techniques, model engineering, future engineering, model planning, data engineering, all the things. So what happens, this lead towards a no hard-coded business rules. I'm not hard-coding any business rule. Instead, it becomes self-learning and efficient application. Now let's take a look at these roles, the roles that are what I listed here. Business analyst, functional design and specification, who's going to create, senior business analyst, developer, programmer, software engineer, tester, test engineer, build and release person, support engineer. I'm not saying this is how it's going to be, may not needed in the future. It needed in a different form. It needed in a different form. If somebody, okay, I'm not talking abstract people who talk about artificial intelligence in YouTube, all this nonsense. I'm not talking about those people. People who really build artificial intelligence solution at a scale for enterprise. Those people can realize, okay, in my current two projects, okay, in my current two projects, I don't create functional design. I don't create technical design. I don't code anything in a business role. I don't do any testing. I don't do anything build and release and support. All done in a different way. All done in a different manner. In my view, in my view, in the future, these roles are not required. Okay, I'm just telling you my view, and I could be wrong and I could be right, which I don't know at this point. So based on what I have seen in the real world, when I build solutions based on artificial intelligence, either it could be data science, or it could be machine learning, or it could be deep learning, I don't use any of these type of things. All right, let's take a question. So what is the question?
Yeah, hi Jyoti, this is Aparna. Thank you
Yes,
very
sir.
much for the awesome session. I had many questions before, but before I forget the question I have for this particular slide, I wanted to ask.
Sure.
So basically, we understand that AI can be implemented in any of the enterprise which is already there,
Sure.
as well as for the new enterprises, right?
That's right.
But there are these enterprises where you have heck lot of a code, which you're talking about.
Mhm.
There are a lot of migrations happening.
Mhm.
How will you really implement AI and bring it as a future component where they
Sure.
are struggling today, and you yourself are you're telling that it's not matured? So how can we, I come from a commercial background, so
Sure.
how can we explain it to the customers?
Sure. Let's take one example. So SAP, I'm sure Aparna, you heard about SAP, correct?
Yes, Jyoti, that's right.
Yeah. So SAP is a pretty massive, powerful ERP package in industry at the moment.
Right.
SAP is well known for finance and accounting. So that is the core product they build. There are other products they added to this: supply chain, CRM, HR, and many other products they added, but that's fine. As a company, the core product is built on using a kind of their own proprietary programming language called ABAP. So now I'm talking about those rules are hard-coded. I wanted to translate that into more of a self-learning, not hard-coded machine learning kind of a solution. Okay, how do I do this? So Aparna, this is falls under product strategy and roadmap. How do I enhance any product you offer, any service you offer? It is not you're going to be like this forever, correct? You have to make a change. You have to offer something. So in your product strategy and roadmap, this could be one of the things that what you can put forward. You can say, okay, in the next release, we are going to introduce some function of artificial intelligence. So I'm not sure whether you experienced some of the cars that comes out, Tesla. So they were not fully automated. It's not fully autonomous. There's a partial autonomous. Why? So they don't want to use everything from day one. They want to go slowly based on a roadmap. Now take BMW. So BMW also trying to implement autonomous functions, not fully autonomous function, some function. For example, when you're driving a car, if you're changing a lane, if you're trying to move to another lane, okay, what happened? The car pulls you back to the same lane. What is that? That's a new function they added. So conversion is not an overnight game. Okay, you sit down and convert and move everything into this one. That is not how it's going to happen. You identify the key function which you want to move into AI, and then continue to build a product portfolio and a roadmap. And these are the next releases going to be. In the next releases, these functions are going to be fully autonomous. And next releases, these functions are going to come like this. So I would approach in that way than doing a massive transformation or massive conversion. So that may fail also. You may not be able to achieve.
Yeah, totally agreed with the roadmap, what you're talking about, Jyoti. Definitely, it's not a one-day change that we can bring in. But again, I have a lot of questions in that form, and I don't want to disturb this session. So can I connect with you offline?
Yeah, we can connect offline.
Sure. Thank you.
No problem. All right. So the two other participants have questions. Let's take those questions and then we'll move on. This is an important topic, right? As I said, I'm not trying to scare you. I'm not trying to say this is something that global view, it's my view. Okay, it's my view. So based on the work, what I do, I don't see these roles exist longer time. Maybe 2 years, 3 years, that's it. So after that, company does not going to invest anything on these kind of roles. Yes, next question, please.
Hi, this is Uma Jyoti. So
saying that these are all based upon the data perspective. So when you say there won't be any software engineers in the future, would that also apply for web applications?
So when you say software engineer, Uma, I want to make sure you understand, correct? A software engineer who's expected to code in certain tools. Let's say I'm a programmer. I write software using C or C++ to build business applications, correct? So for example, I want to build an application intake process, okay? So the application intake process, it's a website where user can log in and connect and enter data, okay? I'm just giving an example, hypothetical example. So in that case, what happens? The user comes there, fills out the form, and they get submits. Behind the scene, you have JSP, servlets, like Java programs, core Java is written. So what these programs are doing business validation. That is the point I'm talking about, okay? You don't hard code programs to do business validation or do business process automation. So those things are done by machines. You still need a software engineer who can create programs like this, okay? So who can create programs like this? A software engineer will focus more on training, testing, deploying a model than a software engineer who's going to build automating business processes, business validation, business roles. Does that make sense, Ma?
Yes, thank you so much.
Yeah, the job title software engineers should be there, but what is expected? That is the point. The expectation is not doing a functional design. You need to understand feature engineering. The expectation is not technical design. You have to do model planning, model selection, etc. That's what I'm talking about.
So on the same lines, Jyoti, I have a question about the skills that you described on what is needed for the AI world and the roles that you're describing here. Does it actually fit every role to acquire all those skills?
The skills, all four skills that I said, it's definitely needed. The level of expertise could vary. A business analyst may not be an expert to code these things, okay? A business analyst could be something that at a higher level. The developer could be at a deeper level who can code this one, correct? The skills still remain the same, correct? So you see this one, these four skills, what we talked, that still remain the same. The level of in-depth knowledge and expertise could vary based on these roles. Okay, a business analyst could have less exposure compared to a software engineer or a tester. Okay, so all I'm saying, these roles could be exist in a different format or in a different language. Okay, it may not be an explicitly called business analyst, or it may not be called as a software developer or programmer engineer. It could be called something else. That is one point. Second point, even if the role is called business analyst, what a business analyst will do in data science projects. In a data science projects, the business analyst should be doing the same thing, but the artifacts, the deliverables are different. The deliverable could be feature engineering. Like someone was asking for what the model is going to give us an input, what the expected outputs, correct? So like this, the actual deliverable could be different. The titles could be remain the same. Okay, so in summary, these roles may or may not exist. If it is exist, the expectation is not what is written here. The expectation is not create a functional design and specification. The expectation is do feature engineering. Understand what is feature engineering, document that, and create that such kind of information, etc. That's what expected. Does that make sense?
Yes, it does. Thank you.
No problem. All right. So let's move on. The one point I really wanted to make sure you understand. Whatever I told, you may not be able to believe that. Okay. Now let me give you a real example. Okay. Now let me give you a real example. So when someone asks you to create a report, okay, let's say you're working in a BI team or an analytical team. So they ask you to create a report or something around this one. So what do you do? The first step is you go ahead and build a simple query. What is the query is doing to do? The query is going to read data from a table. let's take that example. How do I do the similar thing in artificial intelligence? Okay, so here I want a volunteer who can explain what is the SQL statement is doing. Can anyone explain to me what is the SQL statement is doing and what is the problem that you see here? I already written on the top. Okay, so this is basically list all the employees in the same salary grade who are getting paid at the same level. Okay, same salary grade, and in the country of United States. Okay, for the Department of Finance. So that's all it's doing. So what I'm talking about, how many people in my department or in my company have similar job title? How many directors? How many VP? How many software engineer? How many manager, etc. That's all it's doing. So what is the problem you see here? Can anyone tell, please? What is the problem you see here?
We are hard coding it to a specific country.
Excellent.
And
Excellent. Excellent. So that is the point I want you to understand. In a traditional software engineering, okay, whatever program you write, it's all hard coded, or it could be something you can use some file, whatever it is, correct? But it's a hard coded. End of the day, somewhere you're managing. It is not self-learning. If I have to do the same thing in artificial intelligence, I don't write the SQL statement. Instead, I use k-mean clustering. What is k-mean clustering does? It finds similar patterns in the data sets and it groups them together. Okay, it finds similar patterns in the data sets, it groups them together. All employees from United States, one group. All employees in finance, another group. All the employees in the same salary group in another group. It forms 3 groups. Group 1, employee from United States. Group 2, within this, a subgroup of group 1, employee of finance department. And group 3, employee of same salary grade, it groups up together. The group 3, unknown to me, it could be one group, it could be n group, I don't know that. That's why it's K means clustering. K means clustering, it forms a cluster. So now you can understand the difference between traditional software and an AI-based approach. So this is what I was kept on saying. I don't write business rules in my program. Instead, I use statistical data analysis. In both the cases, whether it's a traditional software engineering or the AI approach, the underlying data structure is same. The underlying data structure is same. In both the cases, I have the employee data, I have the salary data, I have the department data. That is not changed. That is not changed. So that is the reason I said, no matter what you think, what I think, what everybody thinks, that is irrelevant. These roles not required. These roles are not required. Even if it is required, the expectation is not writing SQL. The expectation is use statistical data analysis technique. Using statistical data analysis technique. As I said, this level of in-depth analysis, nobody done it. Okay, it's all people talk about. If you go out and look for YouTube or any of these articles, they all talk about, like, learning, neural net, learning, CNN, all these things. Yes, we do need that, but we do need to understand what's going on behind the scene. Correct? So in the future, if you have to create such report, list all the employees in the same salary grade for the US finance department. If that is the automation that is required, I would not write SQL statement. I would write simple k-mean clustering model, which does the same thing in my case. In both the cases, the underlying data structure is the same. I hope now you understand the difference between a traditional software engineering and an AI-driven approach. Okay, so again, I'm not trying to scare you, but I really want you to understand what is hard-coded means and how that is going to be removed from programming and how those things will be transformed into AI. So that's really the message. Okay? So this is important for you to understand. In the future, all these approaches, what we are taking to build automation, may be done in a completely different way. This is just one example I'm giving you to better understand. The reason why this is not inefficient, I'm hard coding. Tomorrow, if I want to list another department, I won't be able to list for another department. It's hard coded. Or if it's reading from a file, I have to go and change the file. If I want to change the country to India, US to India, then I have to change here. In this case, it doesn't matter. It doesn't matter what it is. As long as the underlying data is there, it will work. Let's say the underlying data has country, India, as well as US. What happened? It forms 2 clusters. the main cluster will be two, one for India, one for USA. Then within India, it forms the next cluster, which is finance department, or it could be sales department. Whatever it sees the pattern in the data sets, it forms a cluster. And that is why it's called self-learning. And that is why it's called self-learning. So what is the difference between the traditional software engineering and AI-based approach? So one, no hard-coded business rules. I really want you to understand, okay? I really want you to understand, in the artificial intelligence world, I'm not hard-coding any business rules. The machine self-learns, understands what kind of changes it occurred, okay? The third is completely data-driven learning algorithm. Okay, data-driven learning algorithm, not an inefficient human-written code, correct? The SQL statement, who's writing the SQL statement? Someone like us, either you or me or someone who knows about the SQL, we are writing. So what do you call? This is called source code. This is called your source code. In the world of artificial intelligence, I don't write source code. Instead, I create learning algorithm. The learning algorithm is nothing but a data-driven statistical model, statistical data analysis, correct? So the key point to consider, if you look at our software engineering, compare what we are doing now and what's going to happen in future. In the future, I don't have to hard code any business rules, point one. It becomes more efficient. Point two, the machine self-learns, understands the pattern and adapts the changes as and when it occurs. Number three, the machine creates a learning algorithm instead of a human written source code. So in my view, it's a complete change in how software applications are built. And this change is massive. So if you look at our companies, Wipro, Infosys, TCS, Cognizant, I would say 60 to 70% of the workforce, okay, 60 to 70% of the workforce falls in this category. Okay, either a business analyst or a senior business analyst or a developer or a tester, whatever this, and that's all they're doing. Now you could understand, imagine the impact it's going to make, correct? But keep in mind, it's not the jobs are gone. The jobs are expected to perform something like this, then this, correct? And that is what we are trying to prove. If I am a software developer in a traditional software engineering, if my boss is saying, list all the employees in the same salary grade for the US finance department, and this is what I do. If my boss is asking me to do an AI-based approach, I don't write SQL, I write a statistical modeling tool, and which is nothing but k-mean clustering. In the example, where does k-mean clustering comes into picture? You see this one. So I'm saying here, import the linear regression. Instead of linear regression, I use k-means clustering. I use k-means clustering here. I train them, I test them, I deploy them. And that is how automations are going place. All right, I'll take questions now. Yes.
Jyoti, is there a central place of catalog for these algorithms on what they do, on what the abbreviation, on what functionality does they do?
Yes and no. So it all depends on, like, where you're looking at. So for example, Stanford has NLP, okay? Stanford specialized in natural language processing. So they have list of algorithms, they put it there. And similarly, they also have TensorFlow. So it's going to be collection of several different libraries, several different places, not in a one place, okay? So it depends on what library you're looking for or what model you are trying to build. Deep learning, there's one set of library. Okay, so if you see here in the prerequisite, we put it out there, some of the prerequisite thing that what you could do. So if you notice here, so one of the things that what we told, so you can see here, Anaconda. So what is that? That's basically a programming construct. How do you write Python program and all? Notebook, it's just like, workbook, you can write programs. TensorFlow, this is for the model that what we're talking about. PyTorch, so that's for a deep learning model. TensorFlow, both machine learning and deep learning. This PyTorch is for deep learning. So it is going to be a collection of several different tools. It's just not one tool at this moment, maybe in the future.
Thank you. Are they publicly available? Anybody can access those?
Yes, these are all open source. So you can access them actually.
Okay, thank you.
Yeah. All right, any other questions?
This is Shalini here. I have so on that example, the code, what you showed, right? So for example here, right, if you said the same SQL, if it's done through algorithm, so, but then let's say there's about 100 attributes in that project. So do you train it in general, or do you kind of give the business attributes, like here, the business attributes is probably country and department, right?
Sure.
So how
So,
is,
yeah, so that's based on the model design. When you design the model, so you have to tell and what basis you are going to train the model. So the model will be trained. The model is going to be trained based on employee, department, salary, country, all these things.
okay.
Correct?
So you do give that. Okay.
Yeah, so that's the business attributes. Keep in mind, and that is where the difference between machine learning and deep learning comes. In machine learning, you explicitly tell. In deep learning, you let the machine figure this out.
Oh, okay. Got it. That helps. Thank you.
Jyoti, this is Kasturi, a newbie question.
Yes, ma'am.
So in the sequel, if we were to parameterize this value, I'm just trying to understand how different is it. That's one question. The second one is when you are doing the clustering, are we creating another set of copy of the data compared to the base data that we have? When we approach that, or is it the clustering done like dynamically, or will this approach increase the storage needs in the long run?
Wonderful. So well thought through questions. This is all in memory. Nothing gets stored in a physical disk. It does not increase the data storage. So it's basically all happens. The clustering is formed in a memory. So that's why for a machine learning type of a systems, the memories need to be higher. So answer to your first question, does this require storage or it's going to happen in memory? Yes, the entire clustering is formed in memory. It does not store anything until if you want it to store. So for example, in my case, for example, you see at the end, I'm going to write everything in a file, importing training data. So I'm just going to show you the one piece of the code. So that is going to write into the file. So here, rolling forecast, write model outcome to a file. You see this one, madam? So if you want, you can explicitly write the model outcome to a file. So let's say you form the cluster. Now the cluster is, where do I keep the cluster data? So if you want to just analyze on the fly and see it, that's fine. If you want to store it, that's fine. Like for example, when you go to Google search, you type something, it brings you. Are you going to store this one? No, I just need what I need. I don't need to store this one. So you have options. Option A, if you are good with model outcome, you can look at it, you can understand, move on. If you want to write to a file, you can write to a file. It's up to us. But just because of running model, it does not increase the storage. It does not increase any other need for an external hardware and infrastructure.
Okay, thank you. What about my first question, which is like a parameterizing, and how is that different than this?
Yeah, so that clearly tells me you are in the you are either doing some kind of a coding or you were already working on some of the software industries, right?
Yes,
anyway. All right, that's fine. So it doesn't matter whether it's parameterized or not. Okay, somebody has to run this one. Okay, the parameter could come from a human or the parameter could come from an INI file. So it's a human dependent. In K-mean clustering, it's not a human dependent. No human involved, correct? The machine itself figures out everything based on the underlying data structure. So if you go on a parameter-based approach, how do you pass the parameter? The parameter could be read by an INI file or a human who's running this program. In both the cases, it's a manual work. So here, no manual work. Do you understand?
Yes, yes, that explains. Thank you.
Yes. All right, any other questions?
Hi.
This is there is a question from Lata. I feel that it will be nice if you could answer that question. She is, can you please provide some advice for people in current roles in the traditional software development? Can transition be related AI roles, especially the business system analysis? Any specific course available? Advice on how to build a portfolio for AI project management role?
Sure. So the current role, what I see here, I don't see in AI projects, any other project that I worked on, I don't see a business analyst, correct? But I do see people are working in data engineering, model engineering, developer, programmer, data scientist, architect, project manager. I see all these roles. It doesn't mean in the future it's not going to change. It might change, correct? So if you are already in software engineering, okay, in any form, depends on what your comfort zone. If you are really good at it, I would say go for data scientist, correct? Let's say I've been in industry for last 15 years. I understand data structure very well. I understand the business process very well. I understand in some extent, in terms of how technology works. Then I would say the best option is learn towards become a data scientist. So what is missing in that case? Only the statistical modeling side of it when to choose what model and how do we apply the model, how to build, train, test, and model. If you understand that part, I'm sure you could easily become a data scientist. So there's no clear mapping between the current role to this one. It's all based on how much we know, what we know. So let's take another example. So I have been a project manager. I've been managing projects. Okay, I understand project lifecycle. I understand project team structure. I understand at a high level technologies. So if I want to transition to this one, I would suggest what is the best way to get started. So in my view, correct, we are offering this course at 3 levels. Okay, so for example, whenever I put something together, okay, so whenever I put something together, so I have 3 views in this one. So there is artificial intelligence. When I expand, there's an executive level, professional level, student level. The executive level course will give you more of high level view on how to build artificial intelligence applications. The professional level gives deeper all things you need to understand. Student is more for someone who's more towards an academic side. Okay, so if you're already in a software engineering management role, such as a project manager or a program manager or a product manager, you don't want to go deeper, you want to stay at a high level, get to know this better. In that case, I would say look for an executive course. That's a tricky part. Okay, as I said, I did teach at many places. The executive courses are very abstract. You wouldn't get in depth, correct? You wouldn't get in depth. So if you don't get in depth, you may not be able to manage the people. You may not be able to estimate time and cost and everything. You have a lot of challenges, correct? So it's just a challenge that you have to overcome. So answer to your question, if you are a project manager, what I would suggest, look for a course which teaches you at an executive level so that you can understand and move on. So that's how the transition is going to take place. Let's say I'm not a business expert, but I'm very data expert. And I also know technology very well. Then the best role would be data engineer. Okay, so I know how to work with large complex data sets. I can work with images, voice, videos, etc. Then I could be a data engineer. So like this, we can pick and choose based on our comfort zone. Okay, so this is how I see. There's no clearly defined right or wrong answer to this one. It's all based on many factors. One point I would say, it's a interdisciplinary study. What is interdisciplinary study means in this case? You do need to know business. You do need to understand data engineering and model, and also computing at a high level. All right, any other questions?
Which would be easier? They are asking for that for a database developer to move to AI ML.
Okay.
Is it like towards data engineering, data scientist skill
So
set?
I would say if you are a hardcore technician, like in a DBA or a data person who doesn't have a lot of business knowledge, only data and technical knowledge, data engineering would be a best option. Data scientist needs real deeper business knowledge. Okay, data scientist is the one who's going to work with the business to understand the business needs and formalize a design. So if you are not sure the business side of it, the best option would be stay at data engineering level. If you go on data scientist, the expectation is you have to handle business also. Handling business needs a domain knowledge. All right, any other questions?
So how is object-oriented programming comes into this place? It looks like AI is fundamental is object-oriented programming. You have
Sure,
yes.
ma'am, I can tell you.
Yes.
So you take a C++, Java, these are all object-oriented programming, right?
Yes.
So that the object-oriented programming, it's more of a software engineering principle, not on AI. A software engineering principle is basically how to build softwares, what are the methodology, what are the process that you use to build the software. So,
More abstract in base.
You could say that. Okay, you could say this. So I would say more of on a technical level. So it is one of the principle or one of the approach to build code. Okay, so how do I write code? I can write standalone or an object reference based. I'm referencing this object, and that is the object I'm going to use and clone. Correct. So the object orientation, it's more of low level software development. Artificial intelligence, it is basically in a different approach than AI, artificial intelligence. Sorry, this approach is what we are talking about, correct? So these are two different areas focus, I would say. Object-oriented programming and artificial intelligence. These are two different approaches, I would say.
Okay, thank you.
All right.
So,
yes.
Sorry, go ahead. So I have a question. So when you get into programming, they suggest you to have some knowledge about algorithm and about all the other areas. But when you come to AI, is there a specific set of algorithm that we need to focus on, or is it same as the basic computer science programming?
So the basic computer science programming may or may not helpful. So that's my next topic, like how artificial changes our education. So what we teach our education, so that may or may not be effective. So going back to when you say algorithm, I want to make sure I understand. So algorithms are nothing but, okay, yeah, statistical model could be used to solve a specific problem, okay? So for example, we talked about product recommendation. When a customer comes to my store, I want to recommend a certain product. So what kind of algorithm I can use? So the model that I'm going to build, it's basically a decision tree model or a neural net model. So these two are statistical modeling technique, which is applied on data. So now it learns and understands whatever it sees in the data, it creates an algorithm. Algorithm is nothing but like your source code, Okay, there are key different elements, right? So number one, problem statement. To solve the problem, what statistical model I need? So that is could be a random forest or a decision tree or a neural net. When you apply this model on a data, it creates an algorithm, and that is called learning algorithm, which is in a traditional software, it's your source code. So these are all three different things, right? So when people say algorithm, which is nothing but a machine, what it learned on a data, it creates as an instruction for itself to understand. That is called algorithm. Does that make sense?
Yes, thank you.
All right. Any other questions?
So I had a quick question. I'm Bhargavi. Thank you so much for a wonderful session today. For the database developer or engineer, you said it'll be good if they are in the data engineer side, right? So in that frame of mind, so should we go on the big data, those kind of area, or which particular thing we should concentrate on?
Sure, definitely big data IoT has a role to play, but I wouldn't say just don't go deeper into that one. Also understand a little bit how the machine learning model works, because ultimate goal is to support machine learning models, correct? So yes, you do need to understand. If you look at my slides, okay, in the skill set, I put IoT and big data, okay? So I do put IoT and big data. You can see IoT and big data is there, correct? So the intent is, how do you work with all different data sets, correct? It is not only an image, it's not only on a data stored in a table or an Excel spreadsheet. It could be anything. Like, for example, customer sentiment. How does a customer feels about my product or a service? That's a sentiment. How does the customer sentiment could be expressed by a customer? A customer can record a YouTube video and publish. Or a customer record a voice and publish. Or a customer take an image and post it. So these are all my sentiment. Or I can go to Facebook and write about it. Or I can write a feedback on your website. All these are all customer sentiment. Now, how do we connect all of those? And that is what data skills. You take video, image, voice, text, connect them, correct? So that is when I see what did the customer say about me. If the customer said something in video, something in audio, something in text, something in image, I should know how to extract and work on it. So point what I'm trying to make. Yeah, as a data engineer, you should know how to deal this kind of all the things what we are talking. Big data, it doesn't talk about all the things what we just discussed. It provides a platform to store and retrieve and manage large complex data set using Hadoop kind of a cluster platform. On IoT, it's just more of a sensor which allows you to manage and connect and read data from a devices or sensors. So this requires, data engineering requires combining all, making data available.
Got it. Thank you.
No problem.
So there is one more question by Sujita. What software testing tools are used for AI testing? You did that.
I don't use any software testing. So like, for example, in this case, I'll show you quickly what I'm using right now. So we use different tools. Okay, so that allows me to test and deploy. So you can see Sublime. So here I can build model and build graphs and test and deploy. So there is no specific software testing tool. So what this allows me to do, so this allows me to, when a model predicts, I want to plot a graph and see how the model is predicting an accuracy. Or if I'm looking for something, what is that it's doing? So I can
2 minutes அப்புறமா கோபி போடு.
keep your phone on mute.
Please. I mean, please go on mute.
Yeah, so there is no specific testing tool we use, either some of those open source libraries or something. So here, keep in mind, I'm not going out and testing, okay, whether this criteria is passed or that criteria is passed or this criteria. Each of those criteria could be one model. Each model has to be tested. Each model has to be validated. So I don't see any industry standard tools like what you may have seen. You may have seen Mercury, Load Runner, Wind Runner, Test, all these different tools. I don't see any of those kind of tools. So in my case, most cases I use Sublime, or I can use some of those library which comes along with Python. Okay, Python has a library called MATLAB libs. So that allows me to flat graph and test and see how it's doing. So I don't use any specific software just for testing purpose. There may be other software people could use, but I don't use any of those. All right, anything else?
Rajeshwari, you can go ahead and ask. It's that way it is easier.
Yeah, that's fine. So, sir, regarding that skills, right, I was just trying to map with the existing roles that we have. So I was just wondering what could be the artifact, because you were saying data scientist would a person who will be interacting with the business to understand the problem statement, right?
Yes.
So once they do that, the outcome of that could be kind of a model that they come up in, and then is that the artifact that the data scientist will have to provide?
Yes. So let me give you an example. So the current client that I'm working is a large retail and CPG client. They do both sides, retail side as well as CPG side. So my initial project engagement was helping the customer to do churn prediction. Because of COVID-19, they lost a lot of customers. And the reason they lost the customers, because they were expecting some hygiene products, they don't have it. They moved out. So that happened only when they hit this COVID-19 situation. So they decided to run a model which helps them to understand which customer most likely going to churn and why. So I started the project. So now what happened? That's just a one-line statement they told me. But how do I know what is the criteria for the customer to churn? There could be many factors. So one is poor quality, and second is price increase, and third could be customer service. So the customer service is not good, and the other could be the frequency of invoice. I'm not expecting the customer to pay every month, every week the customer is expected to pay. So these are all different factors. So how do we know these things? Okay, how do we know these things? And that is how you have to go and talk to the customer. Why? When you want to train a model, so the model to be trained based on the hypothesis. A customer who had high customer service call, they churned in the past. A customer who had a high invoice, they are churned out. As soon as the price increase, the customers are churning out. So like this, we have to arrive a state. How do I come and arrive a state? You have to have a business knowledge. You will work with this. So let's tackle your question one at a time. So my first question, my first job, I have to work with the customer to define a problem statement. That includes churn prediction based on this criteria, such as based on invoice, based on billing, based on customer service, based on feedback, etc. So what is that? That's my hypothesis. So that is my hypothesis. When billing goes up, I see there's a customer churn. When pricing goes up, there's a customer churn. Like this, I want to arrive. So that is my first artifacts, is identifying what data I need and what is the level of detail I need based on the problem statement. So number one artifacts, define the problem statement. Number two artifacts, define the data set that's required, the level of detail, frequency, etc. So once I have these two, my next stop was select the right model. What model I'm going to use? I'm going to use a decision tree and a linear regression. Why? I want to try with these two models, simple, easy to implement, and see how the model is predicting. So now I went ahead, build the model. Is the model working well? No. What happened? This is a problem in training data. I got only 3 years worth of data. I asked for 5-year data. Now I'm going back to business. I need 3 months worth of 6 months worth of data. I'm done with it. Okay, so they gave me 3 years worth of data. I got it. I trained, model is working well. I gave the outcome to the business user. Okay, so now how do I give the outcome to the business user? In a form of a Tableau report. So I have to build a Tableau report. So the user can run the report and the model gives them back an outcome, which is a potential customer who's going to churn. Now the business is not happy. Why? I just simply say this customer is going to churn. I didn't tell when they're going to churn. I didn't tell the reason for the churn. Now the business comes back. Can you add in your report when they're going to churn, the reason going to churn? Now I have to go back into the model and do other parameters to be added. You see how this process works? It's a cyclic process. So first step is the skill what you need to facilitate a client communication so that you can define a problem statement. The second part is once you have a problem statement, identifying the relevant data sets, the level of detail what you need. And third is model selection. Once the model selected, then go back with the business model validation and see any enhancements. That's how it works. I hope this helps you.
Yeah, I was able to visualize, but I do have follow-up, but I can connect offline.
Sure, no, what's the follow-up question? Tell me.
No, when we talk about the model, right, it's right away we are talking about the output of the business by creating a Tableau report. So in my mind, between the step 3 and 4, there should also be a data engineering work that needs to happen to
So
have your
there are
data.
several, yes, there are several steps. I did not go everything, right?
Okay, okay.
There are several steps. I like I said, like, I just told the interaction with you on the business, and there is tremendous effort required, correct? In this client that I'm talking about, so they have 13 different systems, okay? 13 different systems. So their customers are people. The customers are in people. The feedback are in an email, or in some cases a web form, in some cases a voicemail, okay? So how do you leave a feedback? So they can call the customer and leave a voicemail, or they can send an email to the customer, or they can fill out an online form. Those are the feedback. That's another system. So the core finance, okay, where the customer transactions are kept, that's in SAP. That's where billing and invoice come to the picture. So I'm talking Siebel, I'm talking SAP, I'm talking in a web application where I can track all the customer feedbacks. And I'm also talking about customer voice as in a voicemail. And then I also have social media feed, okay? So here I have sources for billing, invoice, feedback, social media, almost 7 different sources, okay? So collecting all, building, big deal, correct? We are talking about in a day, it's a global customer, around 15 to 20,000 type of customer feedback, okay? 15 to 20,000 kind of customer, it's a global scale. So dealing such things, it's massive. So I did not walk you through all the steps. I just gave you the interaction that I took on the business side. So with the business, my interaction was defining problem statements. Then in some level, data collection. Next, model validation, acceptance, deployment. That's all. In between, there's a lot of steps out there.
Okay. Yeah, I mean, all I was trying to figure it out is like how I can be in a fit with what I'm currently doing.
I really wanted to ask question because that's why the sessions are correct. Listen, I'm not selling any product here, correct? I'm just trying to share you my real practical experience as a data scientist, how I deal with this kind of problem, what I do, how do we work with them. That's all I'm trying to.
Yeah, absolutely. And really appreciate that because coming from the regular industry background, right? And just trying to have a mind shift towards AI, just trying to compare what is that each role would match to with respect to the AI terminologies.
Sure. No problem. All right. So we have 1 minute left. So time flies. Any other question?
So I have
sorry, go ahead.
Yeah, so you showed that SQL, right? SQL and comparison with the AI.
Yes,
That
yes.
K means clustering.
Yes.
So starting with that, so in the data model, when the data is modeled using AI, so we are just modeling the data, and then clusters will be formed based on that data model.
Sure.
So if we are, so based on one attribute, say for one attribute we have developed a cluster, and then we want to based on the same attribute we want a different type of cluster. So that will also be generated by the data model, right? Whatever.
Yes, yes.
Okay.
Whenever it sees a similarity, it forms a cluster. The
Yes.
number of cluster you can control.
Okay, and then after that, it will be a like UI. You can go and select the clusters, and then it will produce the output.
Right.
It will produce the data set you want, but you can.
That's right.
Okay.
So
Okay.
it could be a UI, or it could write to a file, or you can write to a table. Remember, I was telling you. So in my case, the model outcome that what I have, I'm writing to a file. You see this one?
Okay.
I'm writing to a file. So that is the one I give it to the user, correct?
Okay.
In my case, I do 6-month rolling forecast. So this runs every day. It predicts and writes into a file, and that's an Excel file it's sent to the users. So it could be that.
So the clusters also can be combined together and produce results, right?
Absolutely.
Okay. Okay. Yeah. Thank you.
No worries. All right. So I know it's such a long session. So we do have a session tomorrow morning. Okay, so we're a little behind, but it's not too far. We'll try to cover the remaining topic tomorrow, and we'll move on to data engineering. So I hope you found the session to be very useful. I sincerely want to thank you all. So you stayed since morning, and some of you are East Coast, some are in different time zones. So it's just not that easy. I really appreciate the time you took to attend this class. Thank you so much. I wish you all the best. Good luck. Take care. Thank you.
Thank you. Thank you very much, Mr. Jyoti. It was a very
Thank
long
you.
session. So tomorrow morning we'll start with a little quiz so that you know what you learned today. We might have an interactive session, and then the session continues. Thank you very much. Have a nice day. Yeah.
Thank you all.
Yeah, if you have any questions, don't hesitate. I'm in LinkedIn, or you can mail me, correct? So you can mail me, I'll take care of you. So if any reason, if I'm not able to answer your question, or if you have question to me, just mail me the question, I'll take care.
Thank you all. Thank you for attending. And tomorrow, PST 9:30 or 9:40, we will start. Warm-up session will be going on. With 10 will be Jyoti's. Jyoti will start up the real session from 10. But please do join like same way today so that you can all be ready for the 10 o'clock PST time session. Thank you.
Thank you very much. Take care.
Thank you.
Thank you.
நன்றி ரமேஷ். இவ்வளவு அழகான நிகழ்ச்சியை எங்களுக்கு ஒருங்கிணைத்து கொடுத்ததற்கு. ஜோதி சொல்லவே வேணாம். என்னடா காலையில சாண்ட்விச், வண்டி ஓட்டுறது, அந்த பெண்களுக்கான நிகழ்ச்சிங்கவும் எங்களோட தினசரி வாழ்க்கையில அதை கனெக்ட் பண்ணி ரொம்ப அழகா வகுப்படுத்தீங்க. ரொம்ப நன்றி. நாளைக்கு சான் பிரான்சிஸ்கோ வளைகுடா பகுதி தமிழ் மன்றம் சார்பாக உங்கள் அனைவருக்கும் நிறைய அன்பையும் நன்றியும் தெரிவித்துக் கொள்கிறோம்.
Thank you so much, Juliet. We really want to thank Mr. Jyoti Periaswamy for the wonderful AA session for women today. Let's meet tomorrow also. We would like to also thank all the guest speakers and other Sangam leaders and all the participants. Thank you so much for joining with us. Thank you.
தமிழால் இணைவோம், ஆள்போல் தலைப்போம். நாளைக்கு சந்திப்போம். நன்றி.
Thank you so much. Thank you.
நன்றி.